So, hello guys. Today is day 19, I suppose. It's not 18, right? It's 19 because yesterday I worked. So, yeah, I'm gonna go and simply continue learning. So, I'll focus up, guys. Today, I think in like 3 hours or so, I need to like do something. So, I will not be like studying for 8 hours, or maybe I will because I don't know, right? I can always study at night too. But if I got things to do, then I need to do it. There is like this one thing bugging me that makes me feel like I cannot study. I mean, like there is something that is bugging me. That do you ever feel like there is something more important to do than studying when you are gonna study? Like you just need to do this thing, but you're lazy, so you're studying. Even if studying is like the way for you to cope, I think that's already wrong. So I think I'm doing the wrong thing. I always think that studying is better than doing anything else. But I guess like we can put importance in things, right? And you can always do that to everything. Like if you got hobbies and stuff, you can always put a priority on it. So I'll just learn now without further ado. Let's start learning. Hmm. Okay.
Oh my god.
Today I'm gonna crush it all, man. I'm gonna be the god scripter, man. I'm gonna conquer everything. Whew.
I want to beat this race. The finish line is right over there, but I'm moving so slow right now. Oh my god. I wish I had the energy to just go fast right now. Wait a minute. What the? Would you like to buy Run Like the Wind for 100 Robux? You know what? That's actually not that bad of an idea. If it means that I can finish this race faster. All right, let's click this. Wait. Whoa, 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 whoa. That was really fast. Oh my goodness. Well, aren't I glad I cheated the system? Okay, sorry about that. Going back to what was happening here with the game. What the game decided to do was it prompted me this purchase. Now, if you remember from our last video with Game Passes, this kind of does look like a Game Pass. But if we do buy it and then the purchase has been successful, we can run extremely fast. But we can prompt the same purchase again, and then we can consistently buy this, regardless of if we have ownership of this product or not. And this is what's called a developer product, where we can basically buy the same product. Repeatedly over and over again, that can give us like some sort of advantage to the game that doesn't require us just to buy it one time. It allows us to buy it multiple times. That's what I'm going to be teaching you how to implement in this video with developer products, and I'm also going to sprinkle in using data stores in this video so that we can track our purchase history. But with that being said, let's go ahead and add dev products to our game. Now that we understand it, let's add developer products to our game. But the first thing we want to do is make sure that our game is published. So if you haven't published your game yet, I advise doing that first before continuing. But if you
Yeah, that's it. We're gonna go to day 18 because I got just a little of published game. I don't know publish a lot of game like I can always use what I already have, right? But I think this is getting too much. Like this is there is like too much thing. But the good thing is like I can learn to like manage my code. So if I see that there is too much thing, then I can simply put it to game passes module. I mean to the module, right? I think I need a module to check the success. But someone told me that data store service is like it's good, but it's not good. You need to use the module of player store service. If I remember that right, player store service. Oh no, it's profile store service. Yeah, people make that. So yeah, I'll learn that later on. But for now, I'll finish this scripting tutorial and then I'll finish the GUI and then I'll use profile store. Yeah. I'll learn every day, man. I'll get better each time.
have already published your game, what we're going to do is go up to game settings, and then we're going to go to security down here, and we want to make sure that we have this enabled, enable studio access to API services. Just make sure this one's checked, and
Hmm.
then we should pretty much just be good to go. All right, so now that we have that set up, let's create our first dev product, and this is going to be located within our monetization tab right here. And then if we scroll down, we can see that there's a developer.
Oh, the dev product is within the pages too. I see.
developer product section here with a create button. So what we're going to do is create this, and then what's going to happen is it's going to automatically create a developer product for us down here in this dev product list. There's no product ID yet because we need to hit save before Roblox creates an asset ID for this product that we can use for our own game. So we have a product name, we have a product ID, and we have a price for it too. And if we want to modify it, we can just click these three dots that are over here, and we can click edit. So we can edit the name of this to be whatever we want it to be. We can just say my first product or something like that, and then we can change the price as well to whatever we want it to be. Maybe like 200 Robux, doesn't really matter too much. So then what we're going to do is hit save. So then what should happen is if we go back to our game settings, go to monetization, then we should see our new product down here, as we called it, my first product, with the product ID. So what we're going to do now is, just like in the Game Passes video, we're going to take this ID so that we can use it inside our game to give to the player. So we're going to hit copy ID to clipboard, and then we're going to just close out of this. So that's basically how we create our Game Pass. Now, in order for us to prompt the purchase for the player, so that like if they're playing the game, we want the UI to drop down so that we can ask the player if they want to buy this. We're going to do this on the local side using a local script. So we're probably going to insert a local script board, and then we're going to just close out of this. So that's basically how we create our Game Pass. Now, in order for us to prompt the purchase for the player, so that like if they're playing the game, we want the UI to drop down so that we can ask the player if they want to buy this. We're going to do this on the local side using a local script. So we're probably going to insert a local script in, let's say, starter player with starter player scripts. We're going to hit the plus sign, and then we're going to insert a local script. So just like with Game Pass service, we need to prompt the purchase to the player. And the way we're going to do that is use a service called marketplace service. So we're just going to say local marketplace service
It's surface.
equals game colon get service marketplace service. And then the next thing we're going to do is get access to our local players. So we're going to say local player equals game.players
Oh, oh, it's the same. It's the same. Even I don't realize that. Yeah, marketplace service.
local player. And then we're going to get the product ID of the developer product we just created. So we're going to say local product ID equals, and then we're going to paste in our ID that we copied from the game settings tab. So this is our initial setup we have so far.
So we can use this module to like have all the product ID and all the game passes, right? So it will be easier. Like if we want to get a game passes, like I really like to make things clean. I really like that because if I can explain properly to people like what this is, what is that, and how simple things is, that is when I know that I have succeeded to become a good scripter. What I mean is like to become a clean scripter. So that's what I'm gonna do, guys. I'm gonna make everything clean. But this is not my game yet. I'm gonna make a game soon after I finish everything. I don't know what game it's gonna be, but it's gonna be my portfolio, of course. I'm gonna make a game. But the genre is still unknown. I'm still not there yet, but I'll get there soon, okay?
What we need to do now is prompt this purchase to the player. And this is actually really easy. All we need to do is just say marketplace service colon prompt product purchase. And then we're going to say open and close parentheses. We're going to pass in our player instance. And then we're going to pass the product ID, which we have this in a variable already. So this is basically how you prompt a developer product purchase to the player. The only thing that's different about this is we're saying prompt product purchase rather than before it was prompt Game Pass purchase. But this time it's going to be developer product.
No, it's Game Pass service. What? What? Game Pass. Oh, from Game Pass purchase, not service. I read that wrong.
So this is the only difference we're going to make here. Okay, but we've just gotten through the easy part. But now at this point, things are not going to be as straightforward when it comes to handling the purchase of this product that we've now prompted. So I want you to imagine how this works. When we prompt the purchase to the player, and then the player does decide to buy this product, we have to essentially send that information to the server so that the server knows that this player has bought a developer product, and we need to be able to process this purchase by creating a receipt of the product the player just bought. And we need to figure out what benefits we want to give to the player for that product that they just bought. And we also need to make sure that the purchase is successful. And there can be a lot of issues that come about when we don't know how to properly handle purchases that don't become successful. So that's something we have to take care of when we're processing the purchases for developer products. I hope that part makes sense. So
This all makes sense. Like if you're already on the Game Pass, I think this one will be the same, right?
with that being said, what we're going to do now is create a script on the right side of the screen. Let's just make this inside of server script service. We're going to hit the plus sign, insert a script, and here's what we're going to do. So let's go to our local script and let's copy the marketplace service declaration and then paste that right into here. And then we're also going to make a reference to the player's service as well. So we're going to say game::get service players, just like this. Okay, so most likely we're going to have more than one developer product within the game. And if that is the case, we need to have functions associated with that developer product for when the player does buy that specific product. Like let's say the player buys a 100 plus walk speed developer product. We need to make a function that pertains specifically to the benefit of obtaining 100 plus speed versus a different product. We use functions for each individual function. So essentially what we need to do is make a table full of product functions. And this is what's going to look like. We're going to say local product functions equals open and close hard brackets. So once we have this, our key for each individual product function is basically going to be the product ID of each single product. So if we were to go back to our local script, this is what our product ID is here. Let's just copy this. And what we're going to do is populate this product function by saying product functions open and close hard brackets, and just copy this. And then what we're going to do is populate this product function by saying product functions open and close hard brackets, and then we're going to paste in our product ID, and we're going to set this equal to a new function open and close parentheses. We're going to pass in the receipt that Roblox has created for this product that the player has created. So we're just going to say receipt, and then we're also going to pass in the player as well, like this, and then we're going to enter. So essentially what's happening here is for our product functions table, our key is going to be a specific developer product, and we're going to set this equal to a function that we're going to
Oh, that's new.
activate if the player does successfully buy this developer product. And so if we want to do this for another developer product, we can just copy this, paste it down here, and just have this be a different product ID. It's essentially the same thing. It's just a matter of what we do in these bodies specifically. So right now we're just going to delete this. We're just going to go with 1 for right now. Okay, so let's say we want this product to give 100 plus speed to the player every time they buy it. Or we can just make it 50. It doesn't have to be 100. So we can just say 50 plus speed for this developer product. What we need to do first is access the humanoid, but we need to do the character first. So we're going to say local character equals player.character. And then we're going to access the humanoid.
Oh, we send the receipt and we also send the player. Okay, I understand. So the function for this. Oh, what makes it different from the Game Pass? What makes it different from the Game Pass is Game Pass is forever and developer product is like every time, right? So we need that function over and over again. Wait, gonna go for a while.
by saying local humanoid equals character, find first child, open close parentheses, humanoid. And then we're going to check if that humanoid does exist. We're going to say if humanoid then, we're just going to say humanoid.walk speed plus equals 50. So this is essentially saying take the current humanoid walk speed and add 50 to that. So by default, the walk speed is 16. So if we add 50, then we will definitely see a very noticeable difference. So we've granted the benefits, but what we need to do is return true so that we know that this purchase has been successful. I'm going to show you why this is important just a little bit. So we're just going to return true. That's basically all we're going to be doing for this. And this is how we create a function that can execute the benefits that we're going to give to the player. Okay, so the next thing we need to do is figure out how we can process the receipts that Roblox is creating for the developer products that the players are buying. We need to do this by creating a function that basically processes the receipts for us and then set that function to a callback for the process receipt property in marketplace service. I'm going to show you what that looks like right now. So here's the first thing we're going to do. We're going to, like I said, create the callback function for processing our receipts. We're just going to say local function process receipt, open and close parentheses, and then what's going to be passed into here is a receipt info table. So then we're going to hit enter like this. And so this is the basic callback into here is our receipts. We're just going to say local function process receipt, open and close parentheses, and then what's going to be passed into here is a receipt info table. So then we're going to hit enter like this. And so this is the basic structure of our process receipt. But now what we need to do is set marketplace services process receipt callback to this function that we just created. So down here we're going to say
What? Wait, I'm lost.
But now what we need to do is set marketplace services process receipt callback to this function that we just created. So down here we're going to say marketplace service dot process receipt equals function that we just created. So down here we're going to say marketplace service dot process receipt equals process receipt. So basically our function that we just created up here. So when we say process receipt, and then every time a player buys something, it's going to pass in a receipt info table that basically tells us information about
Roll back to process receipt for developer product purchase.
about the product the player just bought. And there are two pieces of information that we do want from this. The first one is the user ID, and then the second one is the product
What the hell does this even do, man?
ID of the thing the player just bought. So what we're gonna do is say local user ID info table that basically tells us information about the product the player just bought. And there are two pieces of information that we do want from this. The first one is the user ID, and then the second one is the product ID of the thing the player just bought. So what we're gonna do is say local user ID equals receipt info dot player ID, and then the next one is going to be the product ID. So we're gonna say local product ID equals receipt info dot product ID. Okay, so next thing we're gonna do is get the player using the user ID that we just got. So we're gonna say local player equals players colon get player by user ID, and we're going to pass in the user ID like this. And then we're going to check if this player does exist. So if player, then what we're now going to do is try and get this product function for this developer products that we have here for 50 plus speed. Since now we have the product ID within our control, we're now going to do is try and get this product function for this developer products that we have here for 50 plus speed. Since now we have the product ID within our control to be able to know which products to purchase, which products the player bought. So this is so we're basically gonna wrap this in a variable by saying local handler equals product functions, and then in these hard brackets, what we're going to do is put in the product ID. Like let's say this product ID was this one right here. We're going to put that inside of here, and that's how we're essentially going to find this function for the handler right here. So handler is now set equal to this function. Now that we have our function, let's wrap this in a p call. We're going to say local success comma result equals p call is now set equal to this function. Now that we have our function, let's wrap this in a p call. We're going to say local success comma result equals p call. And we're going to be writing this p call like so. We're going to first pass in our handler function. So we're going to pass in the handler, and then what
Okay, we call. Oh, there is the service.
whatever's going to be after this is going to be the arguments that are inside of this function. So the first one is going to be the receipt info, and then the second one is
Oh, oh, the handler is the function itself, and then the argument is the receipt and the player.
going to be the player. So we're just simply going to pass in the player, and that is how we're going to structure p call. Like so. And we're going to check if this was successful. We're going to say if success, then we're going to tell Roblox that this purchase has indeed been successful. And the way we tell Roblox that this has been successful is we return an enum value that basically says that this is a product decision of it being granted. So this is what it's going to look like. We're going to say return enum.product purchase decision dot dot. And as you can see, there's two results here. So there's not processed yet and then purchase granted. This one is going to be purchase granted because this has been because this has been successful. Not processed yet basically means that the purchase is still happening, but there seems to be some issues going on with it. So we need to make sure that we are handling this situation properly. So we're going to hit purchase granted, and that's basically what it's going to do here. So if this was not successful though, so we're just going to say else like this. We're going to let's say we're going to make an error message here that we're just going to say failed to make the product purchase. And then we can just pass in the receipt info so that we know exactly what kind of so that we know exactly what Game Pass failed from this decision. Okay, and then finally we have to make sure to handle what happens if the purchase has not been granted. We're basically just going to go down here and say return enum.product purchase decision dot not processed yet. So if none of this works in here, like if the player does not exist, if the handler does not work, then it's just going to go down here and return not processed yet, so that Roblox can handle what is going to happen here, so that the player does not get charged if the product does fail. So this is our basic structure for handling our developer product. I hope this made sense to you so far, but let's go back to our local script, and I'm actually going to add a task.wait for like about 2 seconds so that the game gives me enough time to load into the game.
Wait. I don't understand. I don't understand this. Callback to process receipt of developer. Process receipt is a special property in marketplace service that expect to be assigned a single function. This function is the secure server-side callback that handles all developer product purchase. It It is always run by the Roblox server whenever a transaction occurs. It is always run by the Roblox. Okay, yeah. Your function is designed to take purchase information. Yeah, that's true. Where do I get this receipt info though? This here? Like by writing this, you are telling that a Roblox engine, whenever a player successfully purchase any of my developer products, whenever a player successfully purchase of all this, run the code inside this. Oh, whenever whenever a product succeed, we run this. Complete purchase. The Roblox engine securely confirms the payment and then immediately calls the function assigned to here. Oh, we assign
game. So now we're gonna go to the game and see the result of this prompt that's being shown right here. Okay, so it says right here, would you like to buy my first product? I'm going to click this, and then what's going to happen is the purchase has been successful. Now, if I run, you can see that I'm actually moving faster now because I bought the because I bought the developer product. Compared to my walk speed being 16, the walk speed now should be the walk speed should now be 66, as you can see right here, because I successfully bought the developer product. So it's pretty much working as expected, and that's how you handle developer product purchases in your Roblox game. Okay, now let's say we wanted to get product information for a specific developer product so that we can use it to either know what information this product does have, or we can just display it in our game if we have the information to the product itself. What we can do is go to our local script, and we can basically just use a function that Marketplace Service has called getProductInfo, pass in a product ID so that we can get back a table full of information about it. So here's what we're gonna do. We're gonna wrap this in a p call by saying local success, comma, product info equals p call function function open close parentheses enter, and then we're simply just going to return marketplace service colon get product info open close parentheses. So we're first going to pass in our product ID over here, and then we need an info type, and this takes in an enum info type. So we're basically just going to say enum.info type, and as you can see, there's a lot of things we can select from. What we are interested in is product, because that is the product type that we are looking for in this case. So now that we have our product type, let's basically just go. So now that we have our product type, if we want to know what's inside of this table, we can just loop through all of the keys and values that are inside this table. So we're just going to say for key key, comma, value, just like this. So now we have this, let's go into the game and hit play. So what should happen is after the minimum membership, when it was created, is limited, is for sale. There's a whole bunch of stuff we can look at here for this product information. So that is how you can access product information about a specific developer product if you need to use this in your game. So for this last part of the video, it's actually a pretty important one, and that is keeping track of our purchase history for each player playing the game. And product if you need to use this in your game. So for this last part of the video, it's actually a pretty important one, and that is keeping track of our purchase history for each player playing the game. And the reason this is very important is because this is the only way we know if a player has actually bought a product or not. Because Roblox isn't going to do it themselves automatically. It's up to us as the developers to be able to keep track of the purchase history that the player does have. And it's not
Game
as intuitive
passes.
as game passes, so it's going to be a little
Wait,
tricky
what? Not as intuitive.
to keep track of player history. So I'm going to try and walk through so that you can understand how this stuff works. So here's what we're going to do. We're going to go to our script, and at the very top, we're going to get access to the data store service. We're going to say local data store service equals game get service data store service, and then we're going to access and we're going to make a purchase history data store. So we're just going to say local purchase history equals data store service colon get data store open close parentheses, and we're going to call this purchase history. So now we're going to come down here and make a few modifications to our data store open close parentheses, and we're going to call this purchase history. So now we're going to come down here and make a few modifications to our process receipt callback. The first thing we're going to do is figure out how we're going to structure our data store to know if the player has bought this product. Few modifications to our process receipt callback. The first thing we're going to do is figure out how we're going to structure our data store to know if the player has bought this product with like this specific transaction that they've done. With receipt info, there's a property here that's called receipt info.purchase ID. So this is essentially a value that is very unique to this specific purchase that this player is making. So it would be a product that this player bought at this specific time, and it's like anything else that ties into this specific purchase ID that has been generated for us with this receipt. So this is what we're going to use to determine this is what we're going to use to determine this specific transaction that this player has made. So we're going to delete this. So what we need to do is create a player product ID for this specific transaction that this player is making. So what we're going to do is drop two lines and say local player product key. And sorry, I meant to say key, not ID. Like this is going to be the key used for our data store. So we're going to set this equal to a key that looks something like, we're going to say user ID dot dot for concatenation, and then we're going to put in an underscore and then dot dot. We're going to concatenate this again with the receipt info dot purchase ID. So the way this is going to be structured is we're going to have our player's user ID, and then this is going to be separated with the purchase ID, the unique ID of the receipt that of the product that we're buying. And so now down here we're going to make a p call so that we can use get async with the data store so that we know that we're trying to retrieve this exact information from here. So we're going to say local success error message equals p call function open close parentheses, enter. And then what we're going to do is, in order to determine whether this actually was successful or not, we're just going to make another variable up here by saying local purchase equals false, and then we're going to set purchased down here equal to the get async function. We're going to say purchase history colon get async open close parentheses, and as the key, it's going to be our player product ID, like this. And so once we do this, we're going to check if this was successful. So we're going to say if success, then, but not just success, we're also going to say if the purchase was successful as well. And what we're going to do is simply just return the purchase granted down here regardless.
Wait, what the hell does this do? Like tracking purchase history? We have the product key, right? This is the key that is used. So the simple thing about this is we can simply have the user ID and the product ID. Wait, This is not. This is. Oh, okay. This player buy this.
Because if we know that this is already in the data store, then we already know that this is a successful purchase, so we don't have to do anything else after that. So we're just gonna pass it in just like that, and this is already in the data store, then we already know that this is a successful purchase, so we don't have to do anything else after that. So we're just gonna pass it in just like that, and this should be set player product key instead of ID, my mistake. And then what we're gonna do is say else if not success. So if this was not successful, then we're gonna do is simply just print out an error message by saying purchase has not been successful. Just like that. I hope this part makes sense to you. When we are determining the key for this purchase history, it's basically going to be the player's user ID with the purchase ID of this specific transaction. And we're going to check inside of this purchase history data store if this does exist. And if it does exist, then we're basically going to return the value that's passed back from the purchase history using this product key. And purchase is determined by either true or false. So false is if it doesn't exist already, and true if it already does exist in the data store. So that's why we check if it's successful and if it's also been purchased already. Then we're just going to say that purchase has been granted. We don't need to do anything else after that. But if it was not successful, then we're just going to say that purchase has not been successful. So that's only one part of it. But
Oh, if we return something, then this will not be an error message.
with the error message down here, so we can just say error has made sense to you, at least so far. Well, since we do have an error message, we actually could just concatenate this with the error message down here, so we can just say error message like this, because we basically just have it right here. So this is basically one way we can tell more information about this error message if it does ever come down here. Okay, so we have the script down here that basically gives the benefits to the player if they buy a specific product. But what we need to do now is wrap this in a P call by first checking if this purchase is already in the data store. If this purchase was already granted to the player, so that the script doesn't randomly just duplicate the benefits for the player if they accidentally do buy it twice. And we're going to do a second check to make sure that this product has already been granted to the player. And we're going to utilize this using update async, if you remember that with data stores. This is how it's going to look. We're going to drop a line down here before we declare player. We're going to say local success, comma, is purchase recorded equals key call.
Holy shit, there is a lot of to take in, man.
Function, open close parentheses, enter. And then for this boolean right here is purchase recorded. We're going to set this equal to a return value given by this data store's update async function. So this is basically what's going to look like. You can just copy what I do and I'll this equal to a return value given function, open close parentheses, enter. And then for this boolean right here is purchase recorded. We're going to set this equal to a return value given by this data store's update async function. So this is basically what's going to look like. You can just copy what I do and I'll explain what's going to happen here. We're going to say return purchase history, colon, update async, open and close parentheses. We're going to pass in the key of the player product key. And then we're going to, and then the second argument is going to be a function with a passed parameter in here called already purchased. purchased. And then we're going to enter like this. We're going to check if already purchased is true. Then we're just simply going to return true. And then there's going to be more things we're going to do down here just a little. But first, I want to explain what's happening here with this code snippet. So we're basically creating another p call with is purchase recorded. This is going to be a boolean that we're going to return, and we're going to set this equal to a p call function of this return value that's going to be set to is purchase recorded from this update async function. So essentially, what's happening here is with this player product key, this key in particular with this purchase history, if this gets updated, like let's say the value for this product key inside purchase history gets updated, like the value gets updated, is we're going to create a new function with a past argument already purchased for this product key inside purchase history gets updated, like the value gets updated, is we're going to create a new function with a past argument already purchased to then have some sort of return value inside of this update async function to then be placed back into is purchase recorded. Because as you know, if we take the player product key, put it inside purchase history, get the value from that key in the purchase history, that value is going to be placed inside purchase history gets updated. Like the value gets updated. Is we're going to create a new function with a past argument already purchased to then have some sort of return value inside of this update async function to then be placed back into is purchase recorded. Because as you know, if we take the player product key, put it
If we take the player product key,
inside of purchase history, get
put it inside purchase history, yes.
the value from that key in the purchase history.
Oh yeah, we get the value when we update. Yeah,
That value is going to be placed into the function parameter here inside of
yeah.
inside of the parameter for this function that we just created, already purchased. Already purchased is the value of whatever we got from the purchase history using this player product key. I hope that part made sense to you, and it's important that you do understand that part. So
Oh, I understand. So because update async, right? Because update async, we'll always get like this is like true, right? If it's already purchased, then it's already true. Then if it's already true, then it's true. We just simply return true. Yeah, I understand. I totally understand, man. So update async usually is used better than set async because using set async it didn't get the value, but for update async the function is the value that is inside the player product key itself. The player product key inside the purchase history. I understand.
if we see if the purchase has already been successful, then we're simply just going to return true. And if not, then we're going to continue doing more checks down here. So literally what we're going to do is take this code snippet with the granting the benefits for the player. We're going to cut this, paste it down here, and then we're also going to return true down here as well. The granting the benefits for the player. We're going to cut this, paste it down here, and then we're also going to return true down here as well. Like at the very end of this update async function for the is purchase recorded boolean. But since we've structured this a little differently, since we're going to return true no matter what, instead what we're going to do is return a boolean of false if any of these checks go wrong. So instead of this if else statement right here, what we're going to do instead is say if not success or checks go wrong. So instead of this if else statement right here, what we're going to do instead is say if not success or not result, then we're going going to throw in an error saying purchase has been unsuccessful, and then we can write down the product that failed. So we're just going to say receipt info.product ID. And now there's one final step, and that is determining the product decision, because we're not just going to rely on this just being not processed yet all the time. So we're just going to delete this. And what we're going to do instead is make an if else structure here. So the first thing we're going to do is check if it was not successful. Like if this variable, if this success variable here was just not successful, then what we're going to do is give an error by saying purchase data store has been unsuccessful, something like that. And then we're going to return an enum.product purchase decision dot not processed yet. And then we can make another else if is purchased recorded equals nil. So what this means is if the purchase that we did, like if there was no value that was updated in the data store was changed, then we're basically going to also return not processed yet because there's an issue going on with that. So we did, like if there was no value that was updated in the data store was changed, then we're basically going to also return not processed yet because there's an issue going on with that. And then if both of these are not the case, then that means the purchase has been successful. So we're going to say return. We're basically just going to take this and then we're going to return purchase granted. Okay, that was kind of a lot taken, but we have finished our product. We have finished our data store script for handling all of these different scenarios that we might have when it comes to handling our developer product purchases. It is kind of sophisticated at first, but if you do understand what's happening here with the script, then you'll have a much better time implementing this in the future, especially when you incorporate more game passes and you decide to work more analytically with all of these purchases that are happening in your game. So that is basically everything that has to do with developer products, and I hope you found this video to be very informative. Like I said, I hope you found this video to be very informative. It was a bit longer than I thought, but that's because I want you to get a full grasp of how these things work, because I know data stores is one of the most confusing topics to new developers, and so I want to take the time to go through step by step on my understanding of using data stores with developer products and things like that. So if you want to refresh your memory on the basics of data stores, then I will link to my data stores video that I'll have for you right here in this video. But with that being said, I hope you found this video.
Okay. There is indeed a lot of to take in, right? So we need to dissect it one by one, okay? So first of all, we have this game pass module, right? I think let's just make a developer module. So the hell is this receipt, man? Um, what the hell is this receipt again? Um, forget this data store for a while. Let's see what's happening here. We have a product ID, right? We have a product function. So this function will have a key of this with the function of this. And the function will have a receive and a player. What the hell does this receive even do, man? Like this is only a variable, like we pass in something here when we try to get this. So product functions. So here, so this is all inside the process receive, right? Yeah. And then mm, this is just the function. Okay. So all of this, chill, all of this process receive, which take in the receive info. Okay. The receive info is what we get from the process receive. Is that right? Wait. So here in developer product, we have the product ID, right? We prompt it, and we see we return the product info. The product info we get from here, num info type dot product. Oh, this is just to see the product info, right? No one purchased it yet. That is just simply to see the product info. And in the product info, we can see the asset ID, asset type ID, the day it's created, developer product ID, the name. Okay, So this get product invoicing is simply to get the product info. So it's really simple. So there is really nothing to worry here. We just know that we can get the info of the product, and then here we process the receipt, right? Wait, let me read that again. Whenever a player successfully, if it succeeds, purchase the product, then it's gonna run this. Okay. And it will pass its purchase detail. So its purchase detail. So from the purchase receipt, from the process receipt, it will go to the receipt info. Right. So this from the receipt, it automatically have an info which is accepted here. Right. Yeah, it should be right. So this function, okay, this is what we want to do when a player purchase this. So we put it on the functions. So for example, if we print product, so if we print product functions here, here on the server, we have this product ID, and the product ID has a function. Yeah, print product function. So the ID of uh, it- the ID is a function. Okay, okay, I understand that. And the ID is a function. So the function take in a receipt and a player in which the product function is called right here. When is it called? It is called like we have the player, right? Because we have the user ID here. Oh, I think I need to see what is inside the it 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 like returns the purchase info, like it returns the receipt info. So I need to know what is in the receipt info itself, right? What kind of thing is on the receipt info? So the thing is a receipt info is the currency spent, currency type. We have the place where it's purchased. We also have the player ID. We have product ID, right? Um, we have product purchase channel, and we have the purchase ID, right? The purchase ID is like the unique thing, like this is the purchase ID. So the key that we want to use is not purchase ID because we actually want to keep the user and the product Why don't we keep the purchase ID and the user and the product? Okay, so I know that there is this thing in receipt info that makes so much more sense. So much more sense because this process receipt, right? It gives back this info, all of this info, right? The receipt info. So now we can get the user ID, we can get the product ID. Now, if we have the user ID, we can give it is already processed, right? But if it is processed, then we need to give the player this one because the one that we get product ID is this one, right? So this product ID is the product ID that we get from the receipt info. So we can actually give this product function. So this is the handler. The handler is simply the function that we want to give. Like this is the handler. If we have probably like more than one function, like we have another function, then we will give that function this, right? So um, this handler is the function, right? It's this function, and this function accept a receipt and also a player, right? And this handler will have the receipt info that we get from here, yeah, and it will also have the player, which we get the player from the get player by user ID that is already get here. Okay, understand? And then get player by user ID. Okay, this handler we use pcall to actually give the to actually give the player this exact player, right? This exact player this thing. Okay, so the receipt is receipt info. Okay, we don't even need the receipt here because we don't use it. So why can't just the receipt? We don't give the receipt. Like, can we just give the player? Because the receipt. Okay, I have questions like, do we need this receipt info to be passed on to the function itself? Because we don't use it, right? We only use it to, or maybe we can use it like, okay, I suggest like this is simply a function to give speed. Okay, so that's done, right? So what we need to do is actually putting, we need to have a data store to store the transaction history because we already have the receipt info, right? We need to make a player product key and then uh, we want to make the purchase, right? It is false because we don't know if the purchase is true yet, but if it's already there, If it's already inside, then it means that it is already purchased. Then the purchase will become true. Like if you already purchased, then this purchase is simply true because we get async. So the purchase, this one, will become true because we have purchase history, right? Purchase history is a data store service uh, named purchase history. So I need to read things about data store first. Data store. So we need to call the data store service. It's simple. So get data store is like we creating data. So this we create a data called purchase history. And we put it inside of here. Oh, so purchase history is this exactly this, the purchase history inside the get data store. So if we get data store, probably um like if we have a weapon list, probably for example, if we get data store of weapon that is already purchased. Yeah, I generally understand. Um, so we get async, like this is to get like, is it already there? If it's already there for the player product key, like if it's already there, then this should be true because here we return true. Here we return true. Right? Let's forget about this for a while. And if success, yeah, and purchase, if the purchase is already purchased, then we return purchase granted. If not, we say the error message. So this one is one thing. And then we have the success. And then we have this is purchase record. So what do we return here is true or false. Or we return always true. But the thing is, from the purchase history, we update async, get the value, player product key, right? Um, we get the value from before. If it's already true, like if it's already there, right? Then this already purchased is true because it gets the value from this one. So if it's already true, then this will be true. So the purchase is already recorded. Um, so we can get the player by the user ID, yeah, because this is inside the process receipt. If the player, if we get the player, right, then what do we do is we see the handler, which is the product ID that is pass on the, we get a product ID from the receipt info, and we make another pickle here to like handle it safely, like we we grant the player the speed. I don't know what this is for, but it's fine. So why don't we make like if success? It's because if it doesn't success, then mm, this is like we can just assume that this is always succeed, right? We can just assume that this always succeed. So if it doesn't succeed, then just throw an error. This is just sort of a fail safe method, and then it is given. Boom, the superpower is given. After it is given, we return true to this is purchase recorded, right? So this purchase recorded must be true, right? So if not success, somehow this is wrong. Like somehow something failed. Just written error, which will never happen probably, or it will happen, but I don't know how to make it happen, make it like not success. Mm. Then we do this. So if this always written true, but if somehow like this broken, or if it's empty, like it returns nothing, then it is also not processed. And then if it's already true, then return purchase granted, right? And purchase granted means it's done. Holy shish, that's pretty hard. Our character. So the grand speed will have two things inside. Why do? Why the hell we have the receipt though? It is very confusing, man. Grand speed, we have the receipt and the player. Character equals player dot character, and then yeah, and then local humanoid character. If humanoid wall speed, we return true. What the hell do we return true, man? We return true. So this product function, if we call it right here, why the hell do we return true here? Is this gonna be true then? Oh, this is simply to grand speed. Developer product. So the function, we can just delete this. Yeah, it's it's unknown global receipt. Like, what the hell is receipt even, man? Unknown global receipt. Considering assigning to it first. Consider assigning to it first. The hell does that even mean? Man? Oh, this is just like this because it already have this is already the function. So this is just the same as like having this inside here. Oh, okay. Oh no, this should still work. It breaks, and I need to know why. So the problem is not on the grand speed, right? I need to watch this video again, and I need to understand the first thing first. Because dang, the Game Pass one, the Game Pass one, there is a lot of thing to take in, like my brain function, player ID, purchase access. Yeah. Brain player purchase. Yeah, creating a receipt. Yeah, it's just create a receipt, and then we put the receipt inside the purchase history, and that is it. That simple. If it's already there, yeah, the Game Pass one, I think it's pretty simple. Okay, I'm gonna go eat and eat first. See you guys later, man. So, hello guys, I'm back. Wait, why the hell is my mic so loud? Hey! So yeah, I'm back, and you can see this hair. This is a hair of someone that just wake up. Yeah, I just woke up. It is 4 p.m. and I'm gonna continue. This one. Hmm. I think I'm gonna continue first. If I really want to know, like, I think I generally understand what this is, even though I don't think I can like implement it myself yet. I understand like everything. I really understand everything. Like what each one does. It's just I don't think this is damn. I learned so much thing just with this one developer products. I think like the thing is you can put this function like somewhere else, right? And then you can like access it somewhere else, like for example in the module. And yeah, I guess I'm gonna just continue to string functions.
Oh my god, it's a string. It's literally a string on a base plate. Okay, I'm gonna be honest, I don't really know where I'm going with this intro, but if you couldn't guess from the title of this video, this Roblox Advanced Scripting episode is going to cover string functions from the string library that Roblox has provided to us that we can use to read but also modify strings in Roblox Studio. And I'm gonna be showing you 10 of the most commonly used functions from the string library that Roblox has for us to offer. So that being said, let's go ahead and get straight into implementing Roblox Studio. Now that we understand it, let's implement string functions inside of Roblox Studio. So I quickly whipped up a script inside of server script service that has two lines, one for a variable that is set equal to the string hello world, and then we're simply just going to print that string. Now, we don't need to go over what this does, it's very self-explanatory, but I do want to incorporate some string functions to our already existing strings so that I can show you all the different ways you can manipulate strings.
This is day 19, right? I kind of forget, man. Need to see my another account. Oh yeah, this is day 19.
And incorporate them in your Roblox game. Starting with the first function, which is called len, and this is basically short for length. And this function basically counts the length of a string, and the length of a string is determined by the number of characters that are in a specific string. So in this case, this string hello world, it has 1, 2, 3, 4, 5, 6, because we're counting the space as a character, 7, 8, 9, 10, 11, 12. So it should be a length of 12 characters, and that is essentially what this function should return if we use the len function. And this is basically what it's going to look like. So in our print statement, we're simply just going to start by saying string.len. We start with the keyword string and then .len, which is the function name, and then we're going to wrap this in parentheses and put my string as a argument for it. So if we were to go into the game, hit test.
Oh, I can name it then. I mean, panda.
And then hit run, we should see in the output, it should say the number 12, because instead of printing out the string itself, we are printing the length of the string, which is going to be 12. So this is one of the easiest and also most useful string functions to use in Roblox Studio, and I highly recommend you use this in your future games. The next string function is called find, and this function essentially allows us to locate a specific location within a string to find a specific pattern that we want to look for. So let's say we were looking at this string hello world, and we wanted to look for just the hello part. Basically what would happen is, if we use this find function, it's going to return two numbers. It's going to return the index of where it starts to find this word, and then the index of where this word ends. So if you remember how we count indices in a string, we basically start at index 1, and we go up, like, we're just counting numbers basically. So it's going to start at index 1 with h, and then it's going to end at index 5 with the o. And that's essentially what string.find allows us to do. So instead of string.len, we're going to replace this with string.find, and then it's going to take in two arguments. The first one is going to be the string itself, and then the second argument is going to be the pattern that we're looking for. And if you remember, the pattern is hello, which is what we're trying to look for. So if we go into the game now and hit run, what should happen in the output is it returns back two numbers. Like I said, it returns back two numbers, the first one being the starting index of where we start to find this pattern, and then the end location of this pattern that we're looking for. And we can be more specific about this too. Like if we just want to look for were, like in world, then it's going to give us the starting and ending index of just those characters inside of the string. So it starts at index 7 and then ends at index 9. And so if you really wanted to, you could make two variables like this by saying local start index comma end index equals, and then we can just take string.find, cut this, paste into here, and then you basically now have two variables here separately, one for the starting index and one for the ending index. And that is essentially how string.find works. The next function is called gsub, and this is essentially short for global substitution. So what this function does is it takes a string, and then we pass in a pattern that we're looking for. So if we were to, let's say, look for the word hello, if we wanted to replace this word with a different word, then we're going to go through the entire string, look for this pattern, and then we're going to replace it, and then essentially return back a new string that has a new string that made the changes that we were looking for. And I'm going to show you what this looks like. So we're just simply going to say string.gsub, open close parentheses, and the first thing we're going to pass in is the string itself, my string, and then we're going to look for a pattern, which, let's say, instead of world, what if we want to change this to something different, like brawl dev or something, then we're going to look for the pattern, which is going to be world, and then we have to pass in this replacement. Now, this replacement can be a string, it can be a table, or it can even be another function itself. But I'm going to show you all three examples. The first one is just going to be a normal string. So I'm just going to replace this with brawl dev, and so what should happen is it's going to return the new string that's modified, but it actually returns two values. So the first one is going to be the new string itself, and then the second one is going to be all three examples. The first one is just going to be a normal string. So I'm just going to replace this with brawl dev, and so what should happen is it's going to return the new string that's modified, but it actually returns two values. So the first one is going to be the new string itself, and then the second one is going to be the number of occurrences that or the number of changes that have happened to the string, because we might find hello world like this, so it'll just change it twice instead of once, and so that's going to keep track of how many times it's been recorded. It's going to be in the second variable, so we're just going to call this one num occurrences equals, and then string.gsub, so we can print the new string, and we can also print the number of occurrences like this. So if we go into the game, hit run, then what we should see in the output is first the new string. So it's going to say hello brawl dev because there's two worlds, so we changed it both times, and then it returned the number of occurrences that have changed with the string. Now, if let's say we wanted to look for any word and not just a specific word, like if we want to look for hello, world, all that sort of stuff, like as long as it's spaced out by a space and these are all individual words that we're trying to look for, then what we can do is use a special pattern that allows us to capture that. So I'm just going to comment this out. I'm going to and these are all individual words that we're trying to like if we want to look for hello, world, all that sort of stuff, like as long as it's spaced out by a space and these are all individual words that we're trying to look for, then what we can do is use a special pattern that allows us to capture that. So I'm just going to comment this out. I'm going to copy this, paste it down here. Instead of having the pattern just be the string world, what we want to do instead is make this a word identifier. And this is essentially what it's going to look like. We're going to put in a percent symbol, W, like W stands for word, and we're going to add a plus sign indicating that we can have more than one word that we look for. I'm going to explain in more detail what this identifier means, but this is essentially how you capture any word inside of a string. And we're going to replace whatever's inside here with with whatever the replacement is on the right. So we hit run, then everything should say brawl dev, just like that. So that is how that works. Now, if we, let's say, wanted to make a table, instead of having a direct replacement just be a string, we can have a dictionary of tables that tell us that we want to replace hello with something else. Or if we want to replace world with something else, instead of having a direct replacement just be a string, we can have a dictionary of tables that tell us that we want to replace hello with something else. Or if we want to replace world with something else, then we can use a table. So I'm going to comment this out, and I'm going to show you down here that we can indicate any word that's in here, but we can put a replacement dictionary inside here like this. So for each key, it's going to be the word that we're looking for. So in this case, we can say one example being hello. We're going to set this equal to the new string that we want to replace this with. So that's going to be the value. So instead of hello, what if we just want to say greetings like this, and then we'll space this out with a comma, and then we can replace world with, let's say, brawl dev instead. So now, anytime we find a word that matches hello, we're going to replace it with greetings. Anytime we find a word that matches world, we're going to replace it with brawl dev. So now let's hit run and then see our new output. So it should say greetings, brawl dev, and it should have been replaced 3 times because we used a dictionary to allow us to change specific words in the string. Here's another cool thing we can do. We can put this in a function that basically says whatever word we find in here, then we can put this in a function and return a new value based on the outcome of this function that we get. That basically says whatever word we find in here, then we can put this in a function and return a new value based on the outcome of this function that we give it. I'm going to show you what this looks like. So I'm going to drop a line down here, paste this into here, and then right before it, we're going to declare a new function. We're just going to say local function operation. It can just be anything really, doesn't really matter. And then we're going to pass in a word like this. We're going to hit enter like this. And then what we can do here is basically return a new string by taking the word, and we can concatenate this with, let's say, something random. We can just say word. I don't know, +1. I'm just like thinking of something random off the top of my head right now. So we're going to have the word followed by a space and then in parentheses +1. So we're just going to return that as the new string every single time we pass in a new word into this function. So for our replacement, instead of using a table, we're going to just simply put in the operation function and the rest should do it for us. So now let's hit run and then see our output like so. We should see hello +1, world +1. and then world plus one again. So that is another cool thing you can do with gsub, and I hope this part has been very practical to you so far. The next one is split, and it's actually pretty easy. If we imagine our string to be like this, spaced out by 3 different words, but we wanted to separate all of these words into an array or into a table that we can use to iterate through all of these different words, what we can do is use the split function that basically splits this string into 3 different words inside of a table, and then we can use that table to iterate through all the words. So this is basically what it's going to look like. We're just simply going to say local words, because we're going to return a table, equals string dot split, open and close parentheses. We're first going to pass in the string, and then we're going to pass in a separator, and this can also be a string as well, or just a simple character. So in this case, what we want to separate here is the space, and so this separator is going to tell us that anytime we see a space, we're going to separate whatever was before it into a entry, and then we're going to put that into the table words like that. It's kind of strange by default. I'm pretty sure Roblox has commas as the separator, even though in a lot of other languages they have space as the default. So if you're trying to use space, then you need to specify space if you want to separate the words. So now that we have this, we can basically iterate through every single word that's in the words table like this, and then that's basically all we need to do right here. So if we hit run, then what we should see is that for each entry, it's going to print out all the words that have been separated. So we have hello, and then drops down a line to world, and then finally world again after it was separated. The next two functions are synonymous with each other, and those are upper and lower. So basically what these two functions do is it takes a string and then it changes every single character to be the uppercase or lowercase version of that character. So if we were to basically print out string.upper in this case, and then we pass in my string like this, it's going to take every single character and make it uppercase by force. And then we can basically do the same thing down here with string.lower like this. And then if we go into the game and hit run, we should see in the output that with my string, it's going to first print out the entire string in all uppercase, and then for the lower, it's going to print out every single character in the string in lowercase. I think it's pretty self-explanatory. I don't need to explain too much on this one. The next function is format, and this is actually one of the more difficult ones to understand. And this is something I can make a whole video about, but I'm not going to go too much into detail about it. I'm just going to show you the basics of using string format and how it works. So let's say we have a string up here with hello world, and we wanted to reuse this string to have a specific format, so that if we wanted to use this string for a future use case, or if we just want to use a string that's very organized with this format that we like to have it with, then we use the string format function that allows us to do that. One example of using string format is by we wanted to reuse this string to have a specific format, so that if we wanted to use this string for a future use case, or if we just want to use a string that's very organized with this format that we like to have it with, then we use the string format function that allows us to do that. One example of using string format is by specifying one word in here that we want to change based on where we based on when and where we use this in our code. So instead of world, let's say we wanted to replace this with brawl dev, or we wanted to replace this in a different place with Roblox. Like we want to replace whatever this word is with a different word, but using the same format. What we can do is replace this with a specifier and the type of whatever this is inside of here. So this is basically what it would look like. So since we don't know what this is yet, we can now specify this with brawl dev. We can even specify this with world, and we can even specify this with Roblox, depending on how we use this. And this is basically how it works down here. We can say print string.format, open close parentheses, pass in the string, and then inside of here, we can pass in whatever we want to replace this with. We can basically say world, and we can copy and paste this down here, and we can replace this with brawl dev, and we can also replace this with Roblox. So if we hit run, then we should see all 3 use cases down in the output. So we should first see world, then brawl dev, and then Roblox. So that is one way we can use string format, and there's definitely many other ways we can use this. We can use this to help pad our strings to make it look nice by, let's say, having some padded space before or after a string using flags. We can even use width to specify how long we want a specific part in the string to be. Like let's say we had the number 100, but we wanted it to be longer than 100 for padding reasons. Like if we want to have multiple numbers that had similar padding with 2 zeros, regardless of how big or small the numbers, then we can just add some trailing zeros to here if we want to give a certain amount of width to our formatted string, like so. There's a lot of use cases for this, but I do want you to be aware of the 4 parts that make up a format. It's the specifier, which is indicated by this percentage symbol right here. Then it's going to be the flags, the width, and then the precision. So the specifier essentially is this symbol right here, like I just mentioned. And whatever character we place after that, that's going to specify the type of whatever we want to insert inside of here. So the S stands for string. But if we want to, let's say, specify an integer or number, then we specify using D, or even I in this case. If we want to do a float, we would specify with F, and you kind of get the idea. With this specifier and this data type, we can basically replace it with whatever this second argument is going to be right here. So this float could be 10.5, and it's going to be put inside of here. And you have to make sure that you get the right specifier type with whatever argument you're trying to put inside of these parameters right here. Flags help us achieve certain kinds of formatting. Like let's say we want to add padding to the left side, then what we can do is basically say, let's say we have a print statement down here with string.format like this, and then let's create our own pattern here. If we wanted to, let's say, specify a flag of having a bunch of padded space on the right side of whatever we put inside here, then what we need to do is put down a negative sign, and then we put down the amount of padding we want, a bunch of padded space on the right side of format like this, and then let's create our own pattern here. If we wanted to, let's say, specify a flag of having a bunch of padded space on the right side of whatever we put inside here, then what we need to do is put down a negative sign, and then we put down the amount of padding we want to put in here. So if we, let's say, wanted 10 characters after we put in a value inside of here, so this is going to be the the padding. And then whatever we specify inside of here, we can, let's say this be a number, then we can put on the right side our number, which in this case we could probably just say 100. I'm just gonna whatever we specify inside of here, we can, let's say this be a number, then we can put on the right side our number, which in this case we could probably just say 100. I'm just gonna comment these two parts out really quick. Okay, so let me hit run very quickly, and then we should see the output is 100. But you might notice
This is like a brain.
that there's all of this white space after it because we added a padding to it. And what's interesting about this as well is we can combine multiple flags together. Like another instance of this would be adding zeros to our padding. So we could get rid of this negative flag and instead put a 0 to pad 10 zeros to the left of the number that we have specified here. So if we hit run, then what we should see at the bottom is that there isn't exactly 10 zeros to the left of it, but it has a fixed length of 10 numbers now because 100 makes up 3 of them, and then the 7 zeros pad the rest of them to the left side of the number. And then we have things like precision. If let's say we had a decimal that we wanted to be in the hundreds or the thousands place, like this, or if we want to have a period specifically after the 10 right here, then what we can do is use float point precision, which basically looks like this. If we had a print statement with the string.format like this, and then we basically had our own formatted string like this with a specifier and then a dot. Let's say we want to have a number like this to f, and then we specify the number we have right over here to the left side. So let's say we want it to be 100. Essentially, what's happening here is we first have our specifier, and then we have a period 2, which basically tells us that with whatever float value that we put inside of here, we want to pad it with a dot and then pad it with 2 zeros after we give this number to this format. So if we hit run, then we should see in the output it shows 100.00 because we specified a float point precision with the dot and 2 with also the f afterwards as well. So that's another cool and useful thing you can do with string format. Once again, this is just a very brief overview of string format, but I hope this gave you more insight into using string format for the future. The next function is match. Now this is very similar to find that we had at the very beginning of this episode.
Yeah, okay. I have learned this before, so I think I kinda understand what this is. This is from C. Okay.
So this one right here, because find returned 2 numbers that basically gave us the starting index and the ending index of where they found this matching pattern. But this time, this is just simply going to return the value itself if it does find it in the string. So this is all we're going to say. We're just going to make a print statement right here, and then we're just going to simply say string.match, open and close parentheses. We're first going to put in my string, and then whatever's going to be on the right side is going to be a string pattern. So if let's say we want to find world in hello world, then what it's simply just going to do is return that word, that pattern that it found in the string. So if we hit run, then what we should see in the output is just simply world, because it found world. Now, if let's say we put something that it wouldn't be able to find, like let's say the number 103 as a string, then it should just print out nil because it was not able to find it. So match basically says it either finds the word that's looking for or it just returns nil. And it's just as simple as that. Next up, we have reverse, which basically just takes the string and then it flips the ordering of the characters in reverse. So if we were to print this out, say string.reverse, and then we pass in just one argument, which is just going to be the string, then all that's going to happen in the output is it's going to print out the same string, but in the opposite direction. So it's going to basically just say, so it's basically just going to print hello world in reverse. It's pretty self-explanatory. It shouldn't be that hard to understand. I think you get it. Next function is rep, and this is short for repeat. So basically this takes the string and then it repeats that string over and over again for however many times we specify it with this function. So this is basically what it's going to look like. If we say print open close parentheses string.rep open close parentheses, and then we first pass in my string, and then for the second argument we put down a number here. So we can say 3 in this case. It's going to print hello world, or no, the string is going to say hello world, and then hello world 3 times. So if we run the game, in the output, the one string should just say hello world, and then hello world. So it just simply repeats the string that we pass in with however many times we specify on the right side. The last function I'm going to introduce is gmatch, which is short for global match. And it's, as the name suggests, it's pretty similar to match in how if we found a specific string or even a specific pattern within a bigger string, then we would just simply return that string itself. But with gmatch, what this does is it returns an iterator for us to constantly loop through a big string to return the result of what we're trying to look for within that string. It's especially useful if we provide a formatted string as the pattern. And so here's what we can do. We can essentially write a for loop that can loop through all of the words inside of this string, and then we can print it out into the output, just as a very basic example. So here's what we're going to say. We're going to say for word in string.gmatch, and then in parentheses, we're going to pass in our string and then our pattern, which this is going to be a specifier for any word that we find inside of here. So we're going to use the %sign W, and then we're also going to add a plus flag to it in string.gmatch, and then in parentheses, we're going to pass in our string and then our pattern, which this is going to be a specifier for any word that we find inside of here. So we're going to use the %sign W, and then we're also going to add a plus flag to it so that we know that we can retrieve any word that's past this. So once we do that, we can say do, and we can simply just say print word. And this is a very basic example of using gmatch. So if we hit run, then what we should see in the output is simply just hello world without taking into account the exclamation point at the very end of it, because we're trying to catch words rather than symbols. And with that being said, that should be the 10 most used string functions that the string function functions library has to offer. I hope you found this video to be informative. So with that being said,
Mm,
I hope you understand more about using string functions inside of Roblox Studio. I'll leave a link to the documentation in the description of this video if you want to take a closer look at it. I might make a future video on string format as its own separate video because it is pretty confusing to learn about at first. I encourage you to use these string functions in your Roblox scripts in case you do want to mess around with strings, because that is something you are pretty much going to have to do for a lot of the time you are going to be developing on Roblox. So I hope this video serves you well. If you want to learn more libraries that Roblox has to offer that I've covered on this channel, I encourage you to watch my core teens video that I will have a link for you right here to watch. But with that being said, I hope you found this strings, because that is something you are pretty much going to have. I encourage you to watch a lot of the time you are going to be developing on Roblox. So I hope this video serves you well. If you want to learn more libraries that Roblox has to offer that I've covered on this channel, I encourage you to watch my core teens video that I will have a link for you right here to watch. But with that being said, I hope you found this video to be helpful, and I will see you in the next episode. Take care.
okay. That is pretty simple for an advanced scripting tutorial. Like it just, yeah, it's pretty simple, I guess. Because it's only a string, like string manipulation, right? You can always search a thing that you want to do there. Like, for example, if you don't understand something, you just search, hey, I want to do this with the string. How can I do this? Or you can just use AI. It's actually like pretty simple. The thing is, yeah. Mm, my headset, I don't like using this. I'm I want to change like to a mic soon. If I get a money, I get the money to buy it. But right now, I think I'm okay with this. Like it makes my ear, like this part right here, It doesn't feel good, man. I don't know. I'm gonna stop recording for a while, and then I'll continue later. Okay? Or no. This one is actually pretty chill. I'm gonna continue. The thing that is like bothering me right now, the only thing that is bothering me is this, right? The Yeah, this thing. I am bothered with this headset. So I think I can do this, right? Like I just open this and then I put it like this so you guys can hear me talk. Let me see. Yeah, you guys can hear me talk, but it's smaller. I need to like get closer. I probably hear hello. Yeah. But yeah, I can just do this and I can use my speaker, the sound. Ah, boom, boom. Yeah, let's see if that works. Or I need to change something in the setting.
Whoa, what is happening with my Roblox character?
No, still doesn't work. I guess I need to change it on the sound setting. Mixer. This one.
Right now. Wait, oh my.
Oh yeah, that's it, man. Something is clearly wrong with the speaker because the speaker has this static sound. Wait, let me clean up the space. This is there's too much thing going on here. I guess I'll just do this. This like takes a lot of weight from me because I can learn longer without using uh, this headset. Or maybe I can use an earphone. I always like to use an earphone. Like earphone is fine. I can use it for like hours. Let me try to find it. I'll use an earphone and then this earphone is for the sound and this mic is for the mic. But you guys will not hear me talk clearly. But it's fine because the thing is I need to learn. Okay, I need to study. Okay, let's try this. Okay, that feels really good. That feels nice. Then the sound setting. I think I'm just gonna do this here. Like, and I put it like up here, like this, like this. Nah, no. Yeah, I'll just do this. If I really wanna talk, I will like do this. Okay. Sound from headphones. That's the right.
Goodness, look at this effect on my character right now. Oh my god, it is very performance heavy, but
Wow. Okay, that works. That works.
it's such a cool looking effect. Oh my goodness. The only way I can see this working is if we use a service that basically allows us to create this sort of frame every single millisecond that's in a loop. Okay, but to tell you the truth, I do know what service is causing this to happen, and it's called Run Service. That basically allows us to have time management capabilities and also be able to know about script contexts and just to understand more about Roblox's loop by loop structure. If you don't know what any of that means right now, don't worry. I'm going to go over what all that means so that I can help you understand what is happening here. So with that being said, I'm going to go a little more in depth to help you understand more about Run Service before we incorporate it inside Roblox Studio. All right, let's think about this for a minute. I'm going to try and explain to you a little bit of how Run Service
Why the voice is like very muffled?
is structured so that we have a better understanding of it and how we can incorporate this inside of Roblox
Very, very muffled.
Studio. Okay, so in the past, we've worked with managing tasks and how they execute and when they execute within a Roblox game. We've done things like task functions with task.wait, task.delay that basically determines when tasks are being executed within a script. We've also done the same thing with coroutines that basically act similar in that regard. Run service basically gives us a better understanding of this hierarchy that happens within a task scheduler, and it's important to know what tasks are executed before other ones so that we can incorporate our own custom tasks to execute in this hierarchy as well. And that is essentially what run service allows us to do. So I want to now show you this concept of Roblox's frame-by-frame loop structure, as we can see right over here. So we have a frame happening over here, and then we have one that's happening at the end here that's basically just going to loop back to the beginning, and it's just going to continue executing. What does all this mean? Well, first we have to ask, what is a frame? A frame is basically a unit of game logic that tells us how much work is being done within a specific frame. Now, I'm not going to lie to you. A frame executes so quickly that you won't even realize that a frame has been executed, because this is where the concept of frames per second come in, like, FPS. So when we run things that are 30 frames per second or 60 frames per second, the more frames that are executing per second, the faster, quote unquote, work is being done, because we have more frames to work with when it comes to how much work is being done within a specific time frame of usually per second basis. So when we run tasks are being ran within each frame, and it goes from one frame to the next frame to the next frame and then to the next frame. It's just going to keep on going, and it's going to be recorded every single second that's going to be happening. Within each frame, a frame literally passes by every single like half a millisecond, so you won't even realize it happening. And so with this loop by loop structure, this is how we are able to record how much work is being done per time basis. So now that we have that understanding, we need to understand how tasks are organized and executed based on their priority levels. So let's say with our task scheduler. So our task scheduler has all these different types of priorities when it comes to what task is being executed first.
Scheduler, huh? Where do I learn about that, man? Kind of forgot. Is it on like the beginner's guide?
And which ones are executed last. So the ones that are executed in purple, these are events that we can actually use with our own tasks with this hierarchy that's happening here. So the one at the very top, this is basically what's being executed first. So we have the user input, and then we go down to this list. So with things like rendering, wait states, garbage collection, physics simulation, and then heartbeat. So obviously we know what user input is. It's basically how we detect input coming from the player. So if I'm moving my character, it's detecting the keys on my player. And then it goes on to this rendering stage that basically shows that, these are tasks that are being run before the frame is even shown into the 3D world. And then we have other things like wait states. So these are the task functions that we've worked with in the past. And then we have things like physics simulation. So basically any work that's being done in the 3D workspace with physics and all that. And then heartbeat, which is its own separate thing that we can actually work with in this hierarchy. So these are things I want you to understand. So with this hierarchy, this is all within the task scheduler hierarchy. And this task scheduler is basically thrown into each and every single frame that's being recorded. So with this understanding of the frame by frame loop and also this task scheduler hierarchy, we're able to get a really good understanding of how tasks are being executed within Roblox and how we can incorporate our own custom tasks within this hierarchy. And that is essentially how this structure works with run service. I hope this makes sense to you, because with this understanding, now we're going to be incorporating our own customized tasks in this hierarchy with this frame by frame loop structure. So with that being said, let's go ahead and go straight into implementing our own tasks within this hierarchy that we have going on over here. Now that we understand it, let's incorporate run service inside of Roblox Studio. So I hope my analogy made sense to you when it comes to the frame by frame loop structure and also the way the task scheduler hierarchy goes when it comes to what tasks are done first versus which ones are done last.
Okay. So like frame by frame, right? So it means that if we input something, it is inputted in like one frame, and the other frame is like rendering, and the other frame is like doing something else. Yeah, I think that's it.
So the way this is going to work is we're going to create our own custom tasks and execute them using these events that are colored in purple. So we're going to start at the very bottom, which is going to be the slowest, but also the most commonly used one called heartbeat. Then we're going to step up to steps, and then finally render steps all the way up here. So the thing that's in common with all three of these events is that they execute tasks very, very quickly, and it's based on the user's performance based on the frames per second loop structure that we had going on up here. So heartbeat is the slowest one, but it's also the most commonly used one. So that's what I'm going to show you right now. So here's what we're going to do. We're going to go to model, and we're going to insert a part. Essentially what we're going to do is move this part along the x-axis to constantly move in the negative direction over here so that we can see it happen in real time once we actually run the script. So we're just going to select constantly move in the model, and we're going to insert a part. Essentially what we're going to do is move this part along the x-axis to constantly move in the negative direction over here so that we can see it happen in real time once we actually run the script. So we're just going to select this. We're going to rename this to heartbeat part, and we're going to insert a script inside of server script service. So we're going to hit the plus sign, insert a script like this. We're first going to make reference to the heartbeat part. We're going to say local heartbeat part equals workspace wait for child heartbeat part. And more importantly, we have to make sure that we actually have the run service declared. So we're going to say local run service equals game colon get service, open close parentheses, run.
Run service is one of the most fundamental and crucial service in Roblox, particularly for anything involving game loops, continuous updates, and client-server synchronization. Its primary purpose is to provide standardized, consistent, efficient way to execute code at specific repeating intervals that are directly tied to game engine own frame rendering and physics simulation cycle. So run service, instead of manually using while true do wait, the run service gives you 3 core events that fire reliably every single frame, allowing you to synchronize your logic with the engine. There are 3 core events. The 3 core events fire in a strict sequence every frame or step of the engine loop. They're listed below in order they execute. So heartbeat after the physics simulation step and before the frame is rendered. Moving the camera to follow apart. So heartbeat, it fires in server and client after the physics simulation step and before the frame is rendered. Wait, I don't understand. I think I need to
Service, just like this. Okay, so here's how we run our heartbeat event. We're just simply going to say run service.heartbeat colon connect function open close parentheses. There is one parameter here. It's called delta time. I'm going to go over what this is in just a little bit, but this is the basic structure of how we have our heartbeat event, because this is how we connect an event just like this. Like we pretty much know this. And so next what we're going to do is say that every single time that this is running, we're going to change the position of the heartbeat part. So heartbeat part dot position equals heartbeat part dot position plus vector3.new open close parentheses. We're going to put in a -1, comma 0, comma 0, because -1 on the x-axis will allow this part to go in this direction like this. So if we now go into the game, hit test, and hit run, then what we should see with the part is that it's going to move one stud in that direction.
Yeah, okay, let's see what happens here. Let's see what happened here, okay? So run service. Fires every frame.
Direction very, very quickly. Now, once again, heartbeat is running every single frame. So like I mentioned here before, so every single time a frame is being made, then it's going to move the part -1 in the x-axis, and it's going to do it again and again and again and again. And it's going to run very, very fast. Like if I were to visualize how fast this is, we can do a print here just by saying heartbeat like this, and then we go into the game, hit run. If we look at the output, we can see that it's literally firing like hundreds of times. Like this is how fast heartbeat runs. It's actually really insane how fast heartbeat does run. And keep in mind, this is at the very lowest tier of the task scheduler. So if we go up here, it's going to run even faster than the one down here, which is actually pretty insane. So like I mentioned, the significance of heartbeat is that it's the slowest, but it's also the most commonly used one. And the reason we use heartbeat out of all these other ones is because this comes after physics simulation. So basically, like if we have our player that's already running, that we already had our user input.
Oh, it runs last.
And the reason we use heartbeat out of all these other ones is because this comes after physics simulation. So basically, like if we have our player that's already running, that we already had our user input down for, then heartbeat is going to be everything that comes after this. So that's why we use this one out of all these other ones. Now, here's some tips I have for you when it comes to using this and why we should use it. So if we were to go back to our script, you might think, why don't we just use a while task.wait do like this, and then just copy everything that's in here inside here. We could do this instead of using heartbeat. But once again, if you imagine where heartbeat is inside of this task scheduler hierarchy, heartbeat is all the way down here. But then we consider what's going to be all the way back here with wait states, with task.wait, task.spawn, delay. So you might ask, like, why is there a difference? Like, why is there significance when it comes to this? Let's imagine this in terms of how the script is handling what's happening here. If we were to use a task.wait for this while true do statement, we are literally pausing execution of the script before we go in and try to execute whatever is going on down here. And this is a fixed length, keep in mind as well. So task.wait with nothing in here could be like 0.00001. This is going to be a fixed number throughout the entirety of the game's duration. But if, let's say, one of the players had bad performance issues with their device, where the frames for them run slower than if we had in comparison to a gaming PC that can run really fast. This can run really fast versus somebody who can run very slow with like their iPhone 4 or something. All of these frames really depend on the performance, and that's why run service matters so much when it comes to when tasks are being executed, because it's primarily based on the user's performance of the device that they're playing on. So that's why instead of this fixed length, if we were to, let's say, be playing on a mobile phone, then it would drop down to this versus what it would be like if we were playing on a gaming PC like this. It really depends on what device the player's playing on. So that is a really big difference when it comes to heartbeat over using like a task.wait while loop like this. So here's another tip I have for you. I wouldn't encourage you to use heartbeat or any of these other run events throughout the entire duration of the game. I think it's better for you to wrap this in a temporary connection and then disconnect it whenever you don't need to have it anymore. So here's an example. If I were to wrap this connection inside of a local variable by saying local connection equals run service heartbeat connect function. So as soon as we run the script, we're going to have a variable be set equal to this connection right here, and it's automatically going to fire. So then if we were to, let's say, have a task.wait for about 5 seconds over here, then we're literally going to disconnect this connection so that we can stop heartbeat from continuing after we don't need it for a while. So we're just simply going to say connection : disconnect like this. Like it literally disconnects the connection that we created over here by placing this inside of a variable. So what happens now is if we hit run and then we see this change happen with the part moving so fast in that direction for about 5 seconds, it's literally just going to stop right there because we waited 5 seconds. The connection for heartbeat literally stopped after we decided to hit the disconnect on that connection. So this is very effective if you want to temporarily have events be connected, and you can disable them if you don't want that connection continuing anymore after that. So that's another tip I have for you, and I hope you find this to be useful. Okay, now going back into our heartbeat function, there is this parameter called delta time, and you might ask, what is this thing being passed into the function? Delta time basically tells us how much time has elapsed from the current time versus is the time that it took to start the last frame. So if we were to go back into our script, so basically, whenever this frame fires, it's going to detect how much time has passed from when this frame started versus when this frame started. And so this basically gives us a good indicator of how much time has passed in between these two frames. And this is useful for making precise calculations based on the performance of the player's device. And a really good example I can think of this is if I had, let's say, a part here that rotated based on the player's device performance. So if we were to, let's say, smoothly rotate this part, like let's just imagine this part was smoothly rotating, it's going to either move slowly or fast depending on the player's performance. And this is very useful for optimizing the player's experience depending on their device's performance. So that's a really good example I can think of, but we can incorporate this inside of our script as well. And I'm going to show you how we can do this. So instead of having a fixed vector 3 value with -1 each time the position is being changed, what we can do instead is create a local variable called distance. And we can set this equal to delta time, and then we can have like a multiplier here just by, I don't know, saying like 10 in this case, and then we can replace the -1 here, which is a fixed number, to distance. And I'm also going to make this multiply by -10 so that it goes in the negative direction. Okay, so now that we have this, let's go into the game and hit run and see what happens. So now that we can have like a multiplier here just by, I don't know, saying like 10 in this case, and then we can replace the -1 here, which is a fixed number, to distance. And I'm also going to make this multiply by -10 so that it goes in the negative direction. Okay, so now that we have this, let's go into the game and hit run and see what happens. So now that we have this, the part is moving slower than it should be. Oh, it's actually like in the way of these frames, my bad. So let me actually just move all of these really quick and then hit run again. So now what we should see is this part is constantly going to be moving in this direction until it just stops after like 5 seconds, because it's now dependent on the player's performance. If the player was having a slower device, then this part would have moved even slower than it should have, versus a faster device, then this part would be moving faster because of it. And if we want to just quickly measure like what the delta time actually is, we can just print this out in the output so that we can see how much time is being elapsed before the other frame. So as you can see, it's a very small number if we decide to use heartbeat over anything else. So those are a few optimization tips that I have for heartbeat, and also the explanation of using delta time. I hope this part has made sense to you so far up to this point. Okay, so the next event is stepped, and this comes in before the physics simulation. And so the main difference between stepped and heartbeat is that stepped is executed before all the physics in the game is being executed, while simulation. And so the main difference between stepped and heartbeat is that stepped is executed before all the physics in the game is being executed, while heartbeat is executed after all the physics simulations have been made. So this tells us that if we want to use stepped, this would primarily be used if we want to do something related to physics before executing the actual physics simulation of our 3D world. So in this case, if we wanted to make changes to, like, let's say a C frame of a part, or if we want to move the velocity, or just like other things like that, we would use stepped over heartbeat. And another added bonus to stepped is that this executes before heartbeat. So this executes more frequently than heartbeat at a faster rate. So this one works even faster than heartbeat in a basic sense. So let's do a side-by-side comparison with another part in relation to heartbeat part. So I'm going to duplicate this heartbeat part and move it over here. So let's this executes more frequently than heartbeat at a faster rate. So this one works even faster than heartbeat in a basic sense. So
The message here. It shows the precise order in which everything happens in the game world every single frame. A chef who must prepare a dish and serve it to a waiting customer. The player screen, okay? As quickly as efficiently as possible. The chef, which is the Roblox engine, follow a strict timeline for every dish. Step is the preparation work. This is the moment right before the chef starts cooking. Your code runs here to set up everything the physics engine will use. It fires before physics simulation. What? Hmm. The heartbeat runs after everything. Hmm. Oh, so heartbeat use like health regeneration, cooldown timer, score updates, shielding camera, final position. So render step is the code runs here just before the final image. So before the frame is sent to the player screen. Anything that needs to be perfectly smooth and tight to the camera, the movement will be frame perfect and visually flawless. Runs only on the client. Step is before the physics start. Heartbeat is after the physics finish. So step is best for setting up forces and inputs. Heartbeat is for game logic, general updates, and timers. Step is for setting up forces and inputs. Render step, camera or UI effect. Uh, okay, let's like black box that thing. I think I kinda understand.
So let's do a side-by-side comparison with another part in relation to heartbeat part. So I'm going to duplicate this heartbeat part and move it over here. I'm also going to change the colors of these so that we can differentiate between the two, just like this. And I'm going to call this, we're going to call this connection 2, and then we're going to disconnect connection 2 after 5 seconds, just like we did with the first connection, just like this. And then instead of heartbeat, we're going to replace this with stepped. Now, what's interesting about stepped is that this function gives 2 arguments. So not only does it give the delta time, but it also gives the time. I'm just going to call this duration time because time is a reserved keyword based on Roblox's standards. So this time, not only does it give the delta time, but it also gives the time. I'm just going to call this duration time because time is a reserved keyword based on Roblox's standards. So this time basically tells us that this is how much time has elapsed ever since the game started, but this is how much time has elapsed ever since the last frame was executed. Basically tells us that this is how much time has elapsed ever since the game started, but this is how much time has elapsed ever since the last frame was executed. So there is a difference between the two, and you need to make sure that you do know when to use either one of these things. Now, generally, you don't really need time, but I would still say delta time is pretty important. I'm also going to make reference to the step part. So I'm going to copy this, paste it like this, and then say stepped part, wait for child, stepped part. I'm going to copy this, and I'm going to find every instance of heartbeat part and replace it with stepped part instead, just like this. Okay, so now we have this taken care of. Let's go and do a race. We're going to do a test comparison of how much time will elapse with this happening. Okay, so as you can see, heartbeat is running faster. But what does this tell us? I thought stepped was supposed to be faster. The reason this is happening is because stepped executes a lot faster than heartbeat does. And whenever we are recording the distance, we are using the delta time from the current frame to the last frame. And so
Mhm.
the distance is going to generate heartbeat does. And whenever we are recording the distance, we are using the delta time from the current frame to the last frame. And so the distance is going to generally be smaller than heartbeat, but we're going to need the delta time elapse with this happening. Okay, so as you can see, heartbeat is running faster, but what does this tell us? I thought stepped was supposed to be faster. The reason this is happening is because stepped executes a lot faster than heartbeat does. And whenever we are recording the distance, we are using the delta time from the current frame to the last frame.
So heartbeat is a little bit faster. Eh? Oh, now that makes sense. Now that makes a lot of sense. Like first it's step first, then heartbeat. the step, then the physics engine, then the heartbeat. Okay.
And so the distance is going to generally be smaller than heartbeat, but we're going to be executing this position change more frequently than this one. So as a result, heartbeat executes less. But we're going to be executing this position change more frequently than this one. So as a result, heartbeat executes less, but it has a bigger distance. But
Hell, do you mean heartbeat execute less? That is literally always alternating.
steps has more execution, but has a smaller distance each time we execute, which is really interesting. So in essence, when it comes to knowing which one is faster, there's a lot of variables that tie into it, and there's a lot of definitions when it comes to which one is quote unquote faster. So that's why you need to understand this from the perspective of the hierarchy of like, do you need to make calculations before the physics is actually running, or do you need to make calculations after the physics is running? I would say this is what's more important when you're trying to decide which one of the two you need to use. But if worse comes to worse, if you don't know which one to use, just use heartbeat. Like there's nothing wrong with using heartbeat. This is going to be basically for more specific cases if you do need to use them. So that's hopefully an analogy that helps you understand the difference between step and heartbeat if you decide to use either one of these in the future. So we finally reached the last event on this hierarchy called render steps. And as you can see, this is all the way up here in the hierarchy as being part of the rendering stage of this task scheduling list. So when we use render steps, you can run stuff very fast with this thing, like at a very, very frequent rate. But there's a few things that we need to keep in mind about render steps. So the first thing that's really interesting is that we can only use render steps on the local side. We can't use this on the server side like we've been doing with heartbeat and steps. This can only be done by the local player. So that is one very important distinction to know about when it comes to using render steps is we can only use it on the local side. And so with that being said, I'm going to show you a demonstration of using render steps using GUIs rather than using parts to move them around using physics and all that sort of stuff. So what I'm going to do is go to Starter GUI, hit the plus sign, create a screen GUI. I'm also going to create a text label like this. So that we can see it on our screen. And then I'm just going to align it like right here, like so. And then I'm going to insert a local script inside of the text label. So the first thing I'm going to do is make reference to our screen. And then I'm just going to align it like right here, like so. And then I'm going to insert a local script inside of the text label. So first thing I'm going to do is make reference to the text label equals script. Parent. And I'm also going to take the run service declaration, paste that into here. And then I'm also going to take this task.wait statement and also this connection disconnect statement right here. Okay, so now what we're going to do is right before the task.wait statement, we're going to make a variable called local connection equals run service dot render stepped colon connect.
Oh, this is before the frame is rendered. Oh, I understand that.
Function or heartbeat connection rather than our step. Now, this one only takes in one argument, which is going to be the delta time, which is very similar to our heartbeat connection rather than our steps connection, which has two parameters in there. So now I'm just going to simply calculate a distance, I guess. We can just say local distance equals delta time times 100, like this. And so what do we want to do with this distance? Well, what we can do, we can basically rotate equals delta time times 100, like this. And so what do we want to do with this distance? Well, what we can do, we can basically rotate this part clockwise based on the player's performance so that we know that render steps is working as expected. So first thing we can do is probably just make a print statement here by saying render steps like this so that we actually know how many times this is being run. And then what we can do is say text label dot rotation equals text label dot rotation plus distance, like this. All right, so in order to test this, we're gonna have to go into the game, hit test, and then we have to hit play so that our actual character is gonna be inside the game. All right, so now we have this, we can see that it's constantly to go into the game, hit test, and then we have to hit play dot rotation plus distance, like this.
Mm-hmm. Okay, it didn't run. It didn't run. It didn't run.
All right, so in order to test this, we're gonna have to go into the game, hit test, and then we have to hit play so that our actual character is gonna be inside the game. All right, so now we have this. We can see
Oh, we need to pay because this is client side. Oh, I forgot.
that it's constantly rotating from where it started to constantly just go clockwise like this until about 10 seconds where we just disconnect the connection just like that. But as you can see within this 10-second time frame, it ran very, very frequently. Like I can't even describe how frequently render steps executed, but it executed very, very frequently. At least I can tell you that. Faster than what steps could execute, faster than what heartbeat could execute. But once again, this can only be executed on the local side. So there are trade-offs to using render steps, but I recommend trying to experiment and figure out which ones work best for you when it comes to knowing which event to use, because render steps, it's all the way up here in the rendering process. So you can decide for yourself whether this is the right step for you to use in your scripts, or if you just want to use steps or heartbeat. Like it honestly doesn't really matter too much of a difference which one you use, but it's still good to understand why there is a difference between these three and how this task scheduling hierarchy works. So I hope this part has made sense to you up until this point. So we've pretty much gone over the basics of time management when it comes to run service.
293. Let's try again. 294. Okay. What? Yeah, that is the same. If you transfer frame, then it means that 60 frame per second, right? So 5 seconds is like 300 frame. I see, man. I see, man. So it depends on the frame. Like if we were to like to print the delta time, right? That's why the delta time from the other person computer is way lower. Oh, I'm sorry. I'm sorry. I think I talk really small right there. But what I mean is like here, you can see that the delta time is like wait, not the render step. I don't need to print that, and then we just need to run. Okay. Now, no. Let's find a way to change our frame rate. Dang, okay. Okay, let's do that later, okay? I guess like I kinda understand. I mean I understand, not kinda. I understand like what this is for the camera, this is for the heartbeat is for after everything and step is before the physics simulation.
service and what it has to offer for executing tasks at specific times during specific occasions that we want to execute them. But run service has something else that we may deem to be useful, and that is knowing the context of scripts being executed. And what I'm trying to get at here is run service has properties to tell us if, let's say, we're playing the game in studio, or if the script is being run on the server, or if the script is being run on the client. We can tell based on the context of where the script is being executed. And if that's the case, then we can perform specific tasks based on specific criteria like that. An example I can think of is if, let's say, I was programming a boss battle and it has cutscenes and everything like that, then I'd probably just want to skip the cutscenes if I'm playing inside of Roblox Studio just so that I can test the boss. And that's just one example. There's so many examples you can probably think of if you want to do something specific with your scripts if you're playing in Roblox Studio versus if you're playing in the actual game. And we can do the same thing with knowing if a piece of code in a script is being executed on the server versus if it's being executed on the client. And this is also very useful for module scripts, which I'm going to show you in just a little bit. So for the rest of this video, I'm going to show you these properties that we can use inside of Roblox Studio. So let's go ahead and go straight into that. All right, so let's start with something easy, which is basically determining if we are playing the game inside of Roblox Studio or not. So here's how it's going to work. I'm going to go on the right side and just very quickly create a new script. I'm going to call this script context like this. And then what we're going to do is first make declaration to run service. I can just go to one of my previous scripts and duplicate that, paste it into here. And then here's all we need to say. We can just say if run service colon is studio, open and close parentheses, then print player is playing in studio. And then if we don't do that, then we can say player is not playing in studio. So it seems very easy, right? We just go into the game, hit test, hit play, and then on the output, what we should see. Okay, well, if we just disabled our previous scripts for a minute, let's go back into the game, and we should see that player is playing inside of studio because we are indeed playing inside studio. If you're playing in an actual game, then it's just going to go to the else statement and then go down here by saying player is not playing studio. And not only do we have checks for if the player's in studio, we can also check if the player is, I don't know, playtesting or if they're in run mode, all these different things. We can check for all of these different contexts if we were to have them inside the script to perform different things based on the script. context. So that's one batch of these functions that I'm going to show you here, and it seems to be very self-explanatory. It's pretty easy. Okay, so now I'm going to show you some other ones, like is server and is client. Now, if you've been scripting for a very long time and you've been following this series, I think you know the difference between the server and client is. I don't need to explain this. But we can basically check in a single script if we are playing on the server or if we are playing on the client based on the script's execution and which context we are executing this script from. So kind of like what we had before up here, we could just say if run service colon is server, then we can print that we are on the server. If we say if run service is client, then we can print or just like do whatever's going to be here if we are playing on the client. So both of these are being checked inside of the context of this script, inside server script service. You kind of have to think outside the box a little bit to really understand and to think about when this would be useful. Like when would you want to check if this execution is happening on server or if this is happening on the client? I'm going to show you one example of using this that I find to be pretty helpful. So I'm just going to delete this code that we have over here. And what I'm going to do is create a module script on the right side of replicated storage. So I'm going to plus sign. I'm going to create a module script right over here. And basically the point of this module script is I'm going to create a function. And this is going to check if wherever this function was executed from, whether that's from the server or the client, or we're going to continue with the execution of this function. So I'm going to show you what this looks like of replicated storage. So I'm going to plus sign. I'm going to create a module script right over here. And basically the point of this module script is I'm going to create a function. And this is going to check if wherever this function was executed from, whether that's from the server or the client, are we going to continue with the execution of this function. So I'm going to show you what this looks like. I'm going to say function module dot, we could just say like my function or something like that, open close parentheses, enter. So what we're going to do is get reference to our run service. I'm just going to copy this, paste this up here. I'm first going to say if run service colon is client, open close parentheses, then we're just simply going to return this. And then we're going to make a print statement down here by saying my function has been executed. And you just like have whatever else is happening down here. So let's try and understand what's happening here. When we run my function, it's first going to check if whatever called this function is on the client, then we're just going to return. Because let's say a hacker is trying to execute that they see inside this module script. Well, since they're on the client, if they try to activate client, then we're just going to return. Because let's say a hacker is trying to execute that they see inside this module script. Well, since they're on the client, if they try to activate this function and it sees that it's being activated from the client, then we're just not going to do anything about it. We're just simply going to return it. But if we are executing this on the server, then we're going to drop down here and hacker is trying to execute that they see inside this module script. Well, since they're on the client, all executed, and you can just like have whatever else is happening down here. So let's try and understand what's happening here. When we run my function, it's first going to check if whatever called this function is on the client, then we're just going to return. Because let's say a hacker is trying to execute that they see inside this module script. Well, since they're on the client, if they try to activate this function and it sees that it's being activated from the client, then we're just not going to do anything about it. We're just simply going to return it. But if we are executing this on the server, then we're going to drop down here and then continue off with whatever we were trying to do with our function, just execute it like normal. So now I'm going to show you what this looks like if we were to require this module script and try to execute it. So we're going to drop it like this. And then all we're going to do is just say is that module.myFunction, open close parentheses, just like that. So we are running this on the server. So if we go into the game, hit test and hit play, then what we should see in the output is that my function has been executed because we are playing on the perspective of, well, okay, we're playing on the perspective of the player, but we can see down here highlighted in green, that means this was printed on the server. So my function has been executed by the server as expected. So now let's see what happens if we decide to change is client to is server instead. So that means this can only be executed on the client. So if we go into the output, we can see that player is playing in studio, but we do not see the print statement for my function has been executed because we executed this function on the server. So because we are now seeing if we're trying to be on the client, it's just not going to run. And if we try to do this the other way around too, so I'm basically just going to very quickly create a local script inside of starter player scripts. I'm just going to create a local script. I'm going to copy this run service command here and these two down here. When I'm going to starter player scripts, I'm just going to create a local script. I'm going to copy this run service command here and these two down here. What I'm going to do is just quickly disable my context script inside of service, go to the game, hit test and play. So what we should see in the output is absolutely nothing because we are trying to see if we are executing this on the server. But if we do this the other way around with is server, then what we should see in the output is finally my function has been executed because we are calling this on the client. And we are seeing in the module script if this is a client or if this is not a server, I mean. If this is a client, then we're going to execute what's going to be down here. You get the idea at this point. You kind of have to think a little bit of how you can incorporate is server or all these other context functions inside your script. And so that is another really cool and neat thing you can do with run service that other services do not really provide. So I hope you found this part to be informative as well, and it can benefit you for your Roblox development career journey. I hope you found this episode to be informative. This is one of the more complicated concepts in Roblox studio development, so if you've made it this far into the series, then I gotta congratulate you on that, because these concepts, they're still going to continuously become more and more difficult as time goes on within the series, and you should be proud of it. So to recap what just happened, we learned about the frame-by-frame loop structure that Roblox has. We learned about the task scheduler hierarchy that happens here. We learned about how we can incorporate our own tasks into the task scheduler, and also how we can run certain contexts inside of our scripts to determine what's being executed and how we can execute the script based on the context of where it was executed from. So with everything that I've taught you in this video, I hope you put it to great use inside of your Roblox scripting. And with that being said, that is pretty much going to be it for this episode. If you want to learn more about time management and also executing tasks during specific times within the game, then I encourage you to watch my core routines video, which I will have a link for you right here in this video. But with that being said, I will see you in the next executing tasks during specific times within
Okay, that is run service done. It is actually like pretty simple, but it's not that simple, but it's simple. I don't know where to incorporate these two. Like, I only try to understand everything like little bit by little bit, right? Like, for example, I already learned about remote events. I already learned about remote functions. Yeah, I learned about a lot of stuff, right? There is about like there is local script and server script. Like, we need to understand that, and then we need to understand about removing and destroying instances, and then we have tools, right? We need to rename the tools to handle to make the part. So wait, not the tools to handle, like the part to handle. So what the hell is this? There is equip, unequip, activated, deactivated. There is a lot of event going on. I also learned about task function, which there is wait, delay, cancel, spawn, and defer. Like task.wait, task.delay. You can also cancel the delayed tasks. And spawn is for running multiple loops, right? But if we want to run like hmm, I forgot what it is, like the better one. Is it coroutine? Wait, coroutine is for multi-threading, but I don't think coroutine is used that much. Like, I see that you can like skip it because it is there is something that is better. I don't know. But from coroutine we can like pause it and then resume it. But with spawn you always do it. And remote event, like remote event is pretty simple, right? There is a remote event and then there is a remote function. Remote event is from the client to the server, or the server to the client, or the server to all client. And remote function like just give back things. Okay. And there is sounds. We can play, pause, resume, stop. Like this is all my progress this far. Like global, local, and proximity. Oh, there is global where we can hear everyone, and local only for one player, and then proximity is you can put it inside an item. And then there is collection service, which wait, what is this? With an array of instances with the same tag name. Oh, yeah, there is tags. Get all tags. What can we do with collection service? I kind of forgot, you know. Wait, first of all, I need to save this first. Like save this to day 19. I kind of forgot like what does collection service do? Get tag. Yeah, I know get tag. Like oh, collection service is for like the tag one that you need to like make a coin. Like yeah. If a coin it has tags and you want to put a script inside all of it, you use collection service, right? If I'm not wrong. Routine. Oh yeah. This is one collection service. So collection service can make a for loop. We have this connection, right? I make it. I try it like I make it from it switch color, then it is it is a kill break, then it is not a kill break anymore when I remove the tag. Like we use that git instance, edit and remove signal. Oh, okay, okay. And there is module scripts to get the table inside the module and not the instant itself. To get the table inside the module. And not the instant. Yeah, module script is one I always use. And twin surface, we also have a twin surface, right? It move the part by the duration. With twin surface, you need to make the twin info, right? You can just separate this. So when you actually want to play the twin surface, like it's easy because you only need to have three things. You need to have the part, the info, and the goal. The info is like the duration and the easing style. The goal is the position, like what you want it to be from the origin place, from the original place, and then we just play. Yeah, it's training is pretty simple. And we also have user input service. Yeah, user input input began is day 13, no? Yeah, user input service. If input began, Oh, we use the enum key code is key down. Wait, why didn't I have that? User input service. And the right is key down. There's also user input type. Input ended, input begin, input ended, input begin, input ended. And there is jump request. And then there is mobile button. It's contact engine service. So there is the action name. Context action service. Yeah, when you press A. Wait, what? Oh, we bind action. Context action service bind action. We bind action to the function. We bind action, right? For argument action. And to the mobile and the key press. What do we press to? Okay, unbind action. Yeah, I don't need to remember all of this. I think I can like search it up when I really need it. Okay, and then there is C frames. Yeah, and there is bindable event. Oh, bindable event and function. It's like, oh, bindable is for like from client to client or server to server. Yeah, and then data store service. Then there is our badges, animation, game passes, and there is string, and the last one is run service. Dang, I've learned a lot, man. Like I've learned a lot, but it's I haven't incorporated it to anything yet. I only learned it, then I know the concept. I know that learning is not all about like knowing and understanding. It's also about applying. So one day when I really need those things, I will apply. Like I already know like how this thing works. So when I wanna know something, I can just simply apply it, right? If I really wanna know something, I can just search it up and then I apply it later on because I already know that thing exists. Like I know this thing exists. But there is like a lot of thing, man. Like you really need a lot of experience. And you know what is the best thing to get experience on? You need to spend time on it. You need to study. You need to keep going, keep going. So that's why I'm gonna keep grinding, man. So I'm gonna rest for a while. I'm gonna eat first and then I'm gonna continue, guys. So yeah. See you later. So hello guys, I'm back. It is 9 p.m. right now, and I'm gonna continue one last, okay? I'm actually like pretty tired. Like studying for 4 hours. I mean, like I study, like the video will be probably like 3 hours or so, but I can assure you that I study for way more than that because I study outside the video too. I read stuff and things. But yeah, I'll finish one more chapter and then I'll call it a day and I'll continue tomorrow, okay? But tomorrow videos probably will be like short too, just because I need to go outside. I need to do some things, the thing that I said yesterday. So yeah, I think that's it. I'm gonna continue learning.
Oh, this game has a loading screen. That's pretty cool. Oh, wait a minute. I just saw a move, but now it's stuck at analytics service. Why is it stuck here? Is it going to move at all, or is it just going to freeze? And oh, okay, never mind. It worked. Okay, it just took a little bit of time, but that okay. I was a little bit worried there. I thought it was just gonna break all of a sudden and not allow me to join into the game, which would have sucked. But it looks like things worked out on its own. Okay, but what you just saw there was a loading screen, and I think you know what a loading screen is. It basically shows how much progress that it takes for a Roblox game to load before you actually jump into the game and play. It's a very neat feature to have. It makes your game look more professional, and you're able to add these custom loading screens into your own game so that you can load what you choose to load into the game before anything else. So this tutorial is going to be about loading screens, but more importantly, it's going to be about replicated first because this is the service that we're going to be using
It first.
to make these loading screens. And I need to be able to explain to you how this stuff works. So with that being said, let's go into the video. All right, let's think about this for a minute. I'm going to try and explain the concept of loading things into a game before anything else. And this is being done through a container that I've actually not talked about on this channel yet. And that is called replicated first. So if you were to basically just go into the Explorer, then you can see on the right side that we have replicated storage, which we have used in the past. And I think you know what replicated storage is. It basically allows us to contain assets that we can access either by the server or the client anytime throughout the game. So this can be things like module scripts, it can be things like remote events, remote functions that needs to be accessed by both the server and the client. So it acts as a storage container for that. But now we have something called replicated first, which I have not talked about on the channel yet. And so I think it's important to know the importance of replicated first and why this is different from replicated storage. So now that we have that taken care of, I'm going to explain this entire concept as a whole. So when we are replicating stuff from server client boundaries, we need to be able to use services or containers that allow us to do that sort of stuff. Like I just said, replicated storage or replicating stuff from server client boundaries. We need to be able to use services or containers that allow us to do that sort of stuff. Like I just said, replicated storage does that for us, but replicated first also does that for us, but in its own specific way. And I'm going to demonstrate what that is exactly right now. So what we have going on here is replicated first, obviously, and then we have replicated storage, which is going to be the second place of a container inside the game that allows us to replicate assets across client server boundaries. And so of course, when we're dealing with the server and we're also dealing with the client, when we use replicated storage, essentially this is a container that we can use to have the server and client access to, like I just mentioned. But with replicated first, what's interesting about replicated first is that this is basically used to replicate things onto the client at its first number one priority. So anything that's contained inside of replicated first, it's going to be replicated to any player that joins into the game first thing before anything else gets loaded into the game. So basically, if we were to load anything from the workspace, anything from the server script service, anything from server GUI, anything contained inside of replicated first is going to be replicated to the client. To load anything from the workspace, anything from the server script service, anything from server first thing before anything else gets loaded into the game. So basically, if we were to load anything from the workspace, anything from the server script service, anything from server GUI, anything contained inside of replicated first is going to be replicated to the client first before anything else. So you might ask, what things would be useful to load into the game before anything else? Well, it's as I showed you in the beginning of this video. Loading screens are very good for loading stuff into the game first thing before anything else. And the reason behind this is because when we try to load assets into the game, we don't want to join into the game and then see these assets being loaded into the game before anything else. What we want is a loading screen to basically show up in our face so that we don't see everything else that's being loaded in afterwards, but instead we just see the loading screen because this is the first thing that was loaded into the client. And so another thing that's useful with replicated first is that we can also load things like preloaded assets into replicated first. So I actually should have put this in first here with preloaded assets because this is like a dictionary full of assets that we can load into the game before anything else. So preloaded assets, what are these? Preloaded assets are basically things that allow us to load stuff into the game before anything else, like I just said. So this can be things like loading screens. It could even be things like sounds. It could even be things like decals over here, or just any sort of asset really. It doesn't really matter too much of how you see it. It's basically just any asset that you want to load into the client first before anything else into the game. And so comparing preloaded assets, we can compare preloaded assets to shared assets because shared assets can be used to be accessed by the server and the client in replicated storage. And things that are shared are things like module scripts and things like remote events. And so these are what's being shared across the client and the server through the shared assets inside replicated storage. But for replicated first, we are essentially loading things to the client before the player joins into the game and before anything else is being loaded into the game. So that is essentially the difference between replicated first and replicated storage. I think this will make more sense once we go into the game and actually incorporate this inside Roblox Studio. So with that being said, let's go ahead and get straight into implementing replicated first inside of Roblox Studio. Now that we understand it, let's implement replicated first inside of Roblox. And we're actually going to jump straight into creating a custom loading screen for a good part of this tutorial. So obviously we know what a loading screen is. It's basically a GUI that shows up on our screen first thing when we load into the game, and it's going to load all the assets we need before we allow the player to play the game that they're playing. And so replicated first is a great way for us to do this because we want to load the loading screen before loading anything else into the game for the client. And that's one of the biggest reasons to use replicated first is to create a custom loading screen. So with that being said, let's go ahead and create one. So on the right side of the screen in Start GUI, I'm going to hit the plus sign and I'm going to insert a screen GUI like this. I'm going to rename this to loading screen, and then I'm going to hit the plus sign again, and I'm going to create a frame. So this frame is going to cover the entire screen. So I'm going to make the size with offsets 1 and 1 to the x and y. So it's going to be 1, 0, 1, 0 like this. So it's going to cover the entire screen, and I'm going to change the background color 3, 1 and 1 to the x and y. So it's going to be 1, 0, 1, 0 like this. So it's going to cover the entire screen, and I'm going to change the background color 3 from white to some sort of gray like this. I'm going to hit OK, and I'm going to hit the plus sign again. I'm going to insert a text label, and I'm going to move this alongside here in the middle. I'm going to scale this just a little bit like this. Insert a text label, and I'm going to move this alongside here in the middle. I'm going to scale this just a little bit like this. Move it in the center like so. Okay, and I'm going to go down. I'm going to hit text scale equal to true, and then I'm going to change the background transparency to 1 so that we don't see the background. And then finally, I'm going to change the
Do like here, right?
text color to white like this. Okay, so now that we have this, I'm going to now add a loading bar to this as well so that we can visually see how much progress is being made in terms of loading the assets. So inside of the frame, I'm going to hit the plus sign, insert another frame like this, and I'm going to rename this to loading bar. I'm going to move this. So inside of the frame, I'm going to hit the plus sign, insert another frame like this, and I'm going to rename this to loading bar. And I'm going to move this down here, scale it like this. I'm going to make it fairly sizable, like probably about this big. And then I'm going to move it to the center once again like this. And now we have a loading bar that goes right below the text like that. So this is going to act as the frame of the loading bar, but on top of it, we need to add the actual bar itself. So I'm actually going to change the background color of this to a really dark gray, like probably like almost black like this. Hit OK. And inside of
Mhm.
out of the loading bar, I'm going to insert another text label like this, and I'm going to set the size of this to be exactly the same size of this bar. So it's going to be 1, 0, 1, 0, like this again. I'm going to not have any text for this text label like this, and then exactly the same size of this bar. So it's going to be 1, 0, 1, 0, like this again. I'm going to insert another text label like this, and I'm going
What the hell is the size, man? Already.
to set the size of this to be exactly the same size of this bar. So it's going to be 1, 0, 1, 0, like this again. I'm going to not have any text for this text label like this. And then what I'm going to do now is change the background color of this to, let's say, some sort of green, like this. And then I'm actually going to change the size of this. Instead of 1 to 0, 1, 0, I'm actually going to change the size of this to 0 for the X scale so that it's going to start at the very beginning here. So once we continuously load stuff, it's going to fill up the progress bar until it reaches the very end of it. So that's essentially what this is going to do. And finally, I'm going to rename this text label to just simply bar like that. So now we have the basics of our loading screen done. Now it's a matter of incorporating a local script so that we can actually make this loading bar functional. And so, like I mentioned, for this loading screen, the best place to put this is going to be inside of replicated first. So what we need to do essentially is create a local script so that we can take this frame and then put it inside of the player's player GUI. And so we can have the loading screen be functional for that reason. So on replicated first, we're going to hit the plus sign and we're going to insert a local script. Make sure this is a local script and not a normal script. And I'm going to take this loading screen and I'm actually going to drag it into the local script like this. Okay, and so now what we're going to do is make a bunch of references. So I'm going to delete this here. So there's going to be a few things we need to do first. The first thing is going to be making our references to the services that we need. So we need players and we need replicated first. So we're going to say local players equals game colon get service, open close parentheses, players like this, and then replicated first. So replicated first equals game get service, replicated first like that. Okay, now here's something important we have to do. So when we load into any Roblox game, Roblox already has a default loading screen. So in order for us to make our own custom loading screen, we need to disable Roblox's default loading screen. That way we can add our own loading screen to replace Roblox's default loading screen. And we can do this using replicated first. So what we can do is say replicated first colon remove default loading screen like this, open close parentheses. It's as simple as this. This is all we need to do so that now instead of Roblox loading screen, we're going to be replacing that with our own loading screen. So that's going to be the important step that we have to take here. All right, and now that we have this, we need to make reference to our player and also the loading screen for that player. So what we're going to do is drop two lines. We're going to say local player equals players.local player like this, and then we're going to make reference to the player GUI as well. So we're going to say local player GUI equals player colon wait for child open close parentheses player GUI like this. And so now what we need to do is make reference
There is a player GUI inside a player. I just know that. The hell? Oh yeah, there is a player GUI.
to our loading screen. And keep in mind, this local script is going to be local to the player that joins into the game. And since we only have one loading screen, we need to basically clone this loading screen and put it inside of the player's player GUI as soon as they load into the game. So this is essentially what we're going to do. We're going to say local screen GUI, or we can even just say loading screen. So loading screen equals script colon wait for child open close parentheses loading screen colon clone. So we're actually going to take this loading screen. we're going to clone it and then set the parent of this loading screen to the player GUI. So we're going to say loading screen dot parent equals player GUI, like this. So now the player has their own loading screen whenever they join into the game. And so what we're going to do now is make reference to the text label and the frame that we need in order to update the bar and the text and things like that. So what we're going to do is say local frame equals loading screen, wait for child, frame, and then we're going to make two references. So the first one is going to be the loading text. So loading text is going to be equal to frame, wait for child. And then we're going to make two references. So the first one is going to be the loading text. So loading text is going to be equal to frame, wait for child, text label, like this. And then we're going to make reference to the bar as well. So we're going to set this equal to frame, wait for child, loading bar, wait for child, bar, like this. So we now have all of our references that we need. And now let's get into the functionality of preloading assets into the game. For right now, we can just make this a very basic loading screen by basically having a task.wait statement for about maybe like 5 seconds or so until we quote just make this a very basic loading screen by basically having a task.wait statement for about maybe like 5 seconds or so until we quote unquote load into the game. And then we should be able to destroy this loading screen once the game has been loaded in. So what we can do down here is basically say task.wait for about 5 seconds. And then down here, we're going to say loading text.text equals loading complete. Just like that. And then we're going to set the size of the bar. So bar.size equals udim2. So it's going to take in 4 values using the udim2 constructor. So udim2.new, it's going to be 1, 0, 1, and then 0, just like this. So once we have this taken care of, then what should end up happening is that once we're actually going to add another wait statement here. So task.wait for about 1 second so that we can see this change. Let's actually make it 2 seconds. And then let's destroy the loading screen. So loading screen dot destroy just like this, and that should basically be the end of our script right there. So once we go into the game, hit test, hit play, then what should happen is we're going to be loaded into the game. There's a little bit of space up there, so there's actually something else we need to check off in the loading screen. Screen GUI, and that is ignore GUI inside. If you don't know what this is, then you should go back and watch my GUI tutorial guide on that. But now that we have this taken care of, it basically covers the entire screen. And once we wait for about 5 seconds, it's going to say the loading has been complete. The bar went full all the way to the right side, and then it deleted the GUI loading screen. Now, obviously, this isn't how we want to actually have the loading screen. We want to have actual assets being loaded into the game in real time before we finish the loading screen and have the player play the game like they want to, and things like that. So I'm going to show you how we're going to be able to do this, and it's by using a service called Content Provider, which I'm going to show you what that is in just a little bit. Okay, so we need a way to be able to determine how we can preload certain assets into the game and be able to load each individual bit of asset so that we can see in the progress bar that, this thing is loaded, and then now this thing is loaded, and then now this thing is loaded until we reach all the way to the end once we go through all the assets that we want to load before the player gets to play the game. And so that is basically achieved through a service called Content Provider. And the purpose of Content Provider is to basically load assets that we give it to be loaded in before anything else into the game. And like asset so that we can see in the progress bar that, this thing is loaded, and then now this thing is loaded, and then now this thing is loaded, until we reach all the way to the end once we go through all the assets that we want to load before the player gets to play the game. And so that is basically achieved through a service called Content Provider. And the purpose of Content Provider is to basically load assets that we give it to be loaded in before anything else into the game. And like I mentioned, Replicated First does this job extremely well because it purposely loads everything and replicates it to the client before anything else inside the game. So now that we understand that, what assets do we want to load in exactly? Well, to think of what assets we can load, we can basically just take all the contents that are within the game. So basically anything that has to do with workspace, players, lighting, material service, just like everything here, like anything that's contained inside the game, we can basically load everything that's within each of these containers. And so everything here is basically treated as an asset. And so we can put this inside a table and then throw it into Content Provider so that we can load it in one by one. And so I'm going to show you what this looks like inside of our script when we modify it. So let's go back into our script. And what we're going to do at the top is make reference to Content Provider. So it's going to look like this: local content provider equals game : get service open close parentheses content provider, like this. So now that we have the content provider service, what we need to do is figure out what our assets are. And like I mentioned before, our assets are basically just going to be all of these containers that are within the game. So the way this is going to look is we're just going to say local assets equals game : get children open close parentheses. So this returns an array of all of these different containers. And so when we go through each of them, we're going to go through each one of these containers one by one to load everything that's contained within each one before moving on to the next one. So since assets is a table, what we need to do is loop through all of the contents that are inside of here, all these containers. So I'm going to disable this task.wait for 5 seconds, since this is like basically a fake timer for loading screen, and instead incorporate the real deal. So what we're going to do is make a for loop by saying for index, comma, asset in pairs, open close parentheses, assets, do. So basically what we're going to do is say that we have an index for every single asset that we have loaded into the game, and then we have the asset itself, which is going to be the container. So what we're going to do now is just say content asset that we have loaded into the game, and then we have the asset itself, which is going to be the container. So what we're going to do now is just say content provider : preload async, like this, open close parentheses, and what we're going to do is pass in the current asset that we are going to load, and it's basically going to be a table like this. So we're going to say open close hard brackets asset. So it's important to put in the open close hard we are going to load, and it's basically going to async like this, open close parentheses, and what we're going to do is pass in the current asset that we are going to load, and it's basically going to be a table like this. So we're going to say open close hard brackets asset. So it's important to put in the open close hard brackets when we're specifying what asset we want to load in, and it's going to be each container that's within the Explorer. So once we have this taken care of, then what's going to happen is basically it's going to loop through every single asset, and then it's going to finish loading, and then it's basically going to be done. But now we need to visually represent this so that we actually know that progress is being made in the loading screen. So the first thing we're going to do is basically change the text to say loading text.text equals open and close quotes. We're going to say loading, and then we're going to concatenate this with the name of the asset. So asset.name. So the asset's basically going to be workspace.
Oh, how many assets? This is a number. This is asset now.
Players and things like that, and then we're going to concatenate this again with 3 dots just like this. And so now we know exactly which is being loaded in at this specific point in the loading bar. So now down here, what we're going to do is simply change the progress or the size of the loading bar to fit with the progress of the actual assets that are being loaded. So what we're going to do is note down the progress using the index variable, and also with however many assets are within the assets dictionary or folder, table, whatever you want to call it. So we're going to make a variable by saying local progress equals index divided by the number of assets that are within the assets table. So it's basically going to be like this. So essentially, if we are at the first, second, third, fourth, or fifth part of the explore, so let's say we are in players, this is going to be the second index, and we're going to divide this by the number of assets that are within here. So basically everything here, the number of that, take that and use the index to divide by that. And that's what's going to get us the scale size of the bar. And I hope like you're able to sort of understand like where this calculation came from because of it. So now what we're going to do is change the size of the loading bar by saying bar.size equals udim2.new, open and close parentheses. Oh, and I misspelled udim2, it should be like this. We're going to say progress for the x scale, 0, 1, and then finally 0. So this is basically everything we need in terms of updating our loading to say progress for the x scale, 0, 1, and then finally 0. So this is basically everything we need in terms of updating our loading screen and to properly load stuff into the game once we do this. So once we go into the game, hit test and hit play, then what should happen is we should see a loading screen, and then it's going to load everything into the game before it decides to destroy the loading screen and then finally get the player inside of the game for it to actually start. So this is a real loading screen. It's not a loading screen where
Real asing expectable. Oh, okay.
I basically have a fake timer and then it just loads the player into the game, even though the stuff was loaded in like a long time ago. Like this is a real loading screen. And so now that this has basically been taken care of, this is essentially how we create a loading screen using replicated first and using content provider. And so I hope that you're able to gain some insight into using replicated first, how loading screens are done, and when assets are being loaded into the game first before anything else inside the game. So I hope this tutorial has given you great insight when it comes to that. All right, create a loading screen using replicated first and using content first before anything screen. It's not for do this. So once we go into the game, 0. So this is basically everything we need in terms of updating our loading screen and to properly load stuff into the game once we do this. So once we go into the game, hit test and hit play, then what should happen is we should see a loading screen, and then it's going to load everything into the game before it decides to destroy the loading screen and then finally get the player inside of the game for it to actually start. So this is a real loading screen. It's not a loading screen where I basically have a fake timer and then it just loads the player into the game, even though the stuff was loaded in like a long time ago. Like this is a real loading screen. And so now that this has basically been taken care of, this is essentially how we create a loading screen using replicated first and using content provider. And so I hope that you're able to gain some insight into using replicated first, how loading screens are done, and when assets are being loaded into the game first before anything else inside the game. So I hope this tutorial has given you great insight when it comes to that. All right, and so to end off this video, I'm going to give you a tiny modification challenge that you can try and run. So if you remember at the start of this video, when I showed you the initial loading bar, it showed the bar changing in size, but at a very smooth rate. It wasn't just fixated like I showed you here with the loading bar that we created, and it also changed the color to yellow, but it changed the color in a very smooth way as well. And a lot of that is used using tween service. So what I want you to do is go into the script and basically where I commented stuff out, where it's like you can define tween service, you can tween the bar, you can tween the color change. I want you to try and do these three things before you continue with whatever you're going to watch next. So this is your challenge for today. If you can do this, then you have a great loading screen.
Dang, man.
That you can use. Try and do these three things before you basically where I commented stuff out, where it's like you can define tween service, you can tween the
Interface.
the bar, you can tweak the color change. I want you to try.
How do I use twin surface again, okay? How do I use twin surface again? Why is this a frame, man? This should be like the progress bar, no? Oh, twin the instance. I don't even remember what the instance is, man. No. Ah, will it crash if I open the Roblox Studio again? If it crash, then it crash, man. Oh, doesn't crash. That's cool. So what instance do I want to change? The instance that I want to change is the bar.
Oh, this game has a loading screen. That's pretty cool. Oh, wait a minute. I just saw a move, but now it's stuck at analytics service. Why is it stuck here? Is it going to move at all, or is it just going to freeze? And oh, okay, never mind. It worked. Okay, it just took a little bit of time. But what you just saw there was a loading screen, and I think so. What I want you to do is go into the script and basically where I commented stuff out, where it's like you can define tween service, you can tween the bar, you can tween the color change. I want you to try and do these three things before you continue. Now, if you need a refresher on tween service, I will link that video. If you can do this, then you have a great loading screen that you can use for your own game. So with that being
Oh, the goal is to the progress. I see. Okay, guys, I think that's it. I'm gonna stop for today. I'm really tired now. You guys. Tomorrow. Bye.